a whisper echoes through time, a secret buried beneath the sands, something older, wiser, and more astonishing than we ever imagined. Imagine a civilization so advanced they built monuments that defy age, history, and logic. The Giza pyramids. They stand as silent giants, guardians of secrets lost to the centuries. For centuries we've thought these marvels emerged around 4,000 years ago. But what if they existed long before? Evidence now suggests the pyramids may be remnants of a forgotten world, built before the last ice age, before the Younger Dryas reshaped humanity's destiny. This isn't just archaeology, it's a revelation, an invitation to reconsider everything. Could our ancestors' knowledge be more profound than we dared to believe? Or are these relics whispering warnings from a lost epoch, reminding us that some truths are too powerful to stay hidden? The Giza pyramids stand as a testament to human ingenuity and ambition, representing a pinnacle of ancient engineering that continues to captivate the imagination. These monumental structures are not merely tombs or symbols of royal power. They are markers of a civilization with an extraordinary understanding of mathematics, astronomy, and architecture. To understand their true significance, one must look beyond their size to the deeper historical and cultural meanings they embody. Constructed during Egypt's 4th dynasty, roughly 4,000 to 3,000 years ago, the three primary pyramids, Khufu's Great Pyramid, Khafra's Pyramid, and Menkaura's Pyramid, serve as enduring symbols of the ancient Egyptians' spiritual beliefs, political stability, and technological mastery. The Great Pyramid of Khufu, also called Cheops, remains the largest ever built, once reaching over 160 meters in height. Its precise alignment with the cardinal points, meticulous design, and the enormous amount of limestone and granite used reveal a civilization with sophisticated knowledge and organizational capacity. Beyond their architecture, the pyramids held profound religious significance. They were perceived as eternal homes of the pharaohs, considered divine incarnations on earth. Egyptians believed that upon death, the pharaoh's soul ascended to the heavens to join the gods, especially Osiris, the god of the afterlife. The pyramid's shape, an ascending structure reaching toward the sky, embody the journey of the soul, facilitating its transformation and union with the divine realm. The internal chambers, passageways, and ritual spaces reflect an elaborate spiritual protocol designed to ensure the pharaoh's successful transition into eternity. Their construction marked a technological and administrative revolution. Building such colossal structures required precise planning and a vast workforce. Contrary to popular myth, the pyramids were built by well-organized laborers, not slaves, who worked in rotating shifts. These workers, skilled craftsmen, engineers, and laborers, were fed, housed, and compensated. The logistics of sourcing, transporting, and shaping millions of limestone blocks, some weighing several tons, demonstrated a societal organization and resource management rarely seen elsewhere in the ancient world. The pyramid complex also served as a political tool, reinforcing the divine authority of the pharaoh and state centralization. By commissioning these monumental projects, rulers displayed their divine right to govern and their connection to the gods, thus legitimizing their rule. The grandeur of the pyramids conveyed a message that their power was divinely sanctioned, inspiring awe and submission among the populace and neighboring states. Historically, the Giza pyramids reflect broader developments in ancient Egypt's culture and society. They symbolize a civilization that balanced religious conviction with technological innovation and administrative prowess. Their precise astronomical alignment, especially Khufu's, continues to fascinate scholars. Some suggest their orientation was intentional, aligning with celestial bodies or specific stars linked to Egyptian mythologies. Such precision indicates a sophisticated understanding of astronomy, which was crucial to their religious and ceremonial practices. Furthermore, the construction of the pyramids marked an important milestone in human architectural evolution. They transitioned from modest tombs and mastaba structures to monumental stone architecture capable of lasting millennia. The development of the pyramid shape, the use of large stone blocks, and their internal chambers laid the groundwork for future architectural feats that influenced civilizations beyond Egypt for centuries. Another key aspect of their significance is the insight they provide into ancient Egyptian society and worldview. The pyramids reveal a society deeply invested in the afterlife, with elaborate rituals and beliefs woven into daily life. Hieroglyphic texts found within some tombs, including later pyramid texts, illustrate complex ideas about death, resurrection, and divine justice. They also emphasize the importance of maintaining Mayat, a principle of cosmic order, truth, and harmony, believed to be upheld through proper burial and veneration of the dead. The pyramids also highlight the technological sophistication of ancient Egyptians. The craftsmanship, especially in the finely fitted limestone blocks and internal passageways, suggests a level of scientific knowledge that challenges assumptions about their capabilities. Scholars debate whether primitive methods or advanced engineering techniques, possibly even unknown technologies, were involved in their construction. Over time, the Giza pyramids have become symbols of human achievement, inspiring awe across generations and becoming part of world cultural consciousness. They attract millions of visitors annually, linking ancient history with modern fascination. Their influence extends into art, literature, and philosophy, embodying the enduring human desire to understand the divine and leave a lasting legacy. Their significance also challenges modern assumptions about ancient people's abilities. For centuries, some dismissed the pyramids as miraculous feats beyond human reach, spurring speculation about lost civilizations, extraterrestrial intervention, or mystical technologies. Recent archaeological findings demonstrate that these structures resulted from collective human effort, ingenuity, and cultural cohesion, an inspiring reminder of what ancient societies could accomplish without modern machinery. The Giza pyramids stand as a testament to the importance of legacy and memory in civilizations. They are the ultimate expression of Egyptian obsession with immortality and remembrance. For thousands of years, enduring natural elements, invasions, and upheavals, they remain symbols of a civilization that believed in eternity. Their resilience and ongoing relevance tell a story of human resilience, faith, and the eternal pursuit of meaning. In history's broad tapestry, the pyramids mark a crucial point where spiritual, political, and technological narratives converge. They revolutionized funerary practices, influenced architecture, and provided valuable insights into Egyptian cosmology. Their continued study and admiration underline their importance. They link past and present, reminding us of human transcendence, understanding, and greatness. Their legacy urges us to reconsider perceptions of ancient civilizations, recognizing human potential long before the modern age. By examining their physical presence and the cultural significance woven into every stone, we see that the pyramids are more than tombs. They are symbols of collective aspiration, reflecting a civilization's quest for immortality and mastery over nature's challenges. Their influence extends through history, exemplifying what society can achieve when purpose, knowledge, and effort align toward a grand vision. Ultimately, they stand as enduring monuments to human innovation, faith, and the desire for everlasting remembrance. The construction of the Giza pyramids continues to baffle scholars and archaeologists, not because of a lack of interest, but because existing theories often fall short of fully explaining how these wonders were built. For centuries, explanations have attempted to shed light on the technological and logistical feats behind these monuments, yet many aspects remain elusive or contradictory. Our current understanding of ancient engineering, workforce organization, and societal capabilities seems insufficient to account for the precision, scale, and apparent advanced knowledge evident in these structures. First, consider the size and precision of the Great Pyramid of Giza. It originally stood at nearly 131 meters, making it the tallest man-made structure for thousands of years. The base covers over 13 acres, with corners aligned closely to the 4 cardinal points. Such accuracy is astounding, especially given the tools supposedly available to ancient Egyptians. Conventional theories suggest they used copper chisels, stone hammers, and basic leveling devices to shape and align massive limestone and granite blocks. But how did they achieve such precision without modern laser measurement, surveying equipment, or machinery? The lack of direct evidence for advanced tools leaves a gap in the narrative. Mobilizing, transporting, and assembling millions of limestone blocks, some weighing as much as 55 tons, without wheels, iron tools, or mechanized equipment raises questions. How did they move these enormous stones from distant quarries? Many theories suggest sledges and wet sand to reduce friction, or elaborate ramp systems, yet conclusive evidence for a definitive ramp model remains absent. Straight ramps would require enormous earthworks. Zigzag ramps would need improbably long, steep paths. spiral ramps would demand immense materials and labour. Alignment precision also raises questions. The pyramid's sides are aligned within fractions of a degree of true north, south, east, west directions, an incredible feat given the tools available. How could they achieve such accuracy without magnetic compasses? Theories point to the use of circumpolar stars for orientation. However, consistently achieving such precision across multiple constructions, without evidence of sophisticated astronomical instruments, casts doubt on these explanations. Workforce capabilities pose further challenges. Standard models estimate tens of thousands of unskilled labourers working seasonally over decades, but organising and provisioning such a workforce remains daunting. Archaeological sites at Giza show evidence of well-fed, organised workers' villages. Yet coordinating the logistics, feeding, housing, clothing, of millions over years and having the knowledge to quarry, shape and position stones with such accuracy seems beyond what many believe the ancient Egyptians possessed. Internal construction techniques add another layer of mystery. The pyramids contain complex chambers, passages, and precisely fitted stones. The Great Pyramid's Grand Gallery, Queen's Chambers, and King's Chamber demonstrate architectural mastery that appears advanced beyond contemporaneous Egyptian capabilities. The internal precision suggests knowledge of engineering principles and construction methods that remain debated. Conventional theories propose Egypt's engineering skills developed gradually from earlier pyramids and tombs, but this progression does not fully explain the leaps in design, engineering and organisation needed for the Giza structures. Features suggest an understanding of physics and structural integrity that may have been inaccessible with basic technology. Adding to the enigma is the Laplace or air bass relief method, believed to have been used by Egyptians, involving precise planning and measurements. However, the tools and techniques for such precision are not well documented archaeologically or historically. Could much of their engineering knowledge have been lost or remain misunderstood? Or do these structures indicate influences from an advanced civilization that passed down knowledge? Transporting massive stones remains a major point of debate. The sledges and rollers idea is plausible, but depends on the assumption that the Egyptians had the organisational capacity to move huge blocks over distances. Where did this knowledge of large-scale logistics originate? Were they pioneers, or did they inherit techniques from an earlier civilization that achieved similar feats millennia earlier? Some theories suggest that pyramids serve not only as tombs, but also as astronomical or spiritual devices aligned with celestial events or mystical purposes. If true, this implies an understanding of astronomy and geometry that was advanced for the period. Critics, however, argue such alignments could have been coincidental or achieved through rudimentary methods, questioning whether builders intentionally oriented the pyramids with such precision. Adding complexity is the idea of advanced or even anomalous technology. Some researchers propose the precision and scale hint at lost knowledge or influence from civilizations with higher technology levels. The absence of detailed records and the grandeur of the structures fuel speculation that techniques or tools remain undiscovered or misunderstood. Climate and environmental factors also complicate the story. The deserts surrounding Giza are now arid and stable, but climate fluctuated in antiquity. The logistics involved in quarrying, transporting, and constructing during periods of upheaval or environmental change seem unlikely without sophisticated planning and societal stability. Yet archaeological evidence shows no signs of the chaos that such large-scale work would require. These challenges highlight gaps in our understanding. Existing theories tend to assume that Egyptian engineers, workers, or scribes had technological capacities comparable to early Iron Age civilizations. But the artistry, engineering, and alignment of the pyramids challenge these assumptions. The gaps are not just missing pieces, but suggest current models might be incomplete or flawed. Persistent inconsistencies and contradictions threaten to undermine the idea that the Giza pyramids were built with technology similar to that believed to have been available. Instead, these mysteries suggest possibilities involving lost knowledge, advanced ancient civilizations, or unexplained technologies that challenge our historical frameworks. This ongoing puzzle invites reconsideration of what is possible and urges us to push the boundaries of understanding of ancient engineering, society, and technology. A great deal about our distant past remains hidden, and each discovery raises more questions than answers. The secrets of Giza remain a compelling reminder that history may only be a fragment of a larger buried story, hidden beneath the sands of time. Word count 995. This video isn't just about ancient monuments, it challenges the accepted narrative of human history. Its core purpose is to open a window into a possible different timeline, one where the story of the Giza pyramid's construction could be fundamentally rewritten. Instead of accepting the mainstream view that Egypt's most iconic monuments were built around 4,000 years ago, it examines evidence suggesting they may be much older, possibly predating the Younger Dryas period, around 12,800 years ago. By exploring evidence for an earlier construction date, the video aims to stir debate and question long-held assumptions. It's about re-evaluating the archaeological record with fresh eyes, recognizing that history may be more complex than the linear stories we've been told. Sometimes, accepted narratives fit well into a puzzle, but what if some pieces don't fit? What if our history is just a fragment, and the real story stretches back much further? Examining alternative timelines encourages critical thinking. It pushes us to investigate geological, astronomical, architectural, and cultural clues that might suggest a much older origin for these structures. The goal isn't to discredit ancient Egyptians, but to consider whether their technological marvels, construction expertise, and astronomical knowledge could have roots in much earlier civilizations. It hints that knowledge or cultural memories associated with pyramid building may have been passed down through ancient channels far before the accepted timelines. Another vital aim is to challenge scientific dogma and orthodox history. Mainstream archaeology often resists ideas that contradict established dates, partly because of a lack of definitive evidence and partly due to paradigm inertia. Presenting alternative interpretations of dates, artifacts, and geological phenomena aims to foster skepticism of the status quo. It urges viewers to ask questions. Could there be ancient techniques of construction we've yet to discover? Are clues buried in the sands of time? Might there have been an ancient knowledge system predating known civilizations? The importance of exploring these perspectives extends beyond academics. It taps into human curiosity about how old our civilization truly is, what stories and knowledge might have been lost or misunderstood. Could humanity's most advanced technological or spiritual achievements be far older than acknowledged? The search for early or alternative timelines opens philosophical questions about human history. Could it be more fluid, filled with lost civilizations, vanished technologies, and forgotten wisdom waiting to be rediscovered? This approach suggests much of what we accept as ancient history might be just a chapter in a longer story. Anomalies, like precise astronomical alignments, extraordinary construction methods, or advanced geological knowledge, could be clues to a long-lost global civilization or a past chapter of human progress. These signals aren't mere curiosities. They may hold keys to understanding a broader, more interconnected ancient world. Furthermore, exploring alternative timelines fuels scientific inquiry and debate. Challenging accepted theories can spark new research, excavations, and interpretations. Progress often begins with questioning assumptions and daring to imagine what lies beyond current understanding. The purpose is to ignite curiosity, fostering a questioning attitude toward archaeology, geology, and history, encouraging a more nuanced approach that could lead to breakthroughs in understanding our past. The video also considers that ancient myths, legends, and archaeological evidence hint at a shared or inherited knowledge, particularly astronomical and architectural, that predates accepted timelines. These stories might be distorted memories of a distant advanced past, fragments of a collective human understanding. Rather than fanciful tales, they could serve as clues pointing to a shared history or a lost golden age of achievement, suggesting civilizations may have inherited or preserved knowledge from a much older tradition. Its broader aim is to inspire wonder and possibilities, that humanity's origins might be far more extraordinary than current narratives suggest. If the pyramids and other megalithic structures predate the Younger Dryas, that would imply our ancestors possess skills and knowledge that surpass what we typically assume. This could mean remnants of advanced engineering, astronomy, or science survived or were passed down through hidden means, challenging our view of linear progress and technological development. The dialogue opened by this exploration pushes us to look at ancient sites through a broader lens, considering astronomical correlations, geological formations, and technological capabilities that might have been lost or misunderstood. Shifting perspectives can lead to new hypotheses, insights, and a richer understanding of humanity's shared history. It urges us to look beyond the surface, questioning conventional interpretations and seeking deeper truths. At the cultural and spiritual level, many ancient civilizations contain myths hinting at a distant, golden age. If these stories are rooted in real history, they suggest a collective memory of an earlier, more advanced civilization, perhaps lost to time, but preserved through myth. These stories might be distorted memories, but ultimately connected to real events and achievements of humanity's past. This exploration serves to raise public interest and awareness. Challenging mainstream views becomes a rallying point for thinkers, researchers, and explorers who believe the human story is far richer and more mysterious than current textbooks depict. It seeks to foster independent inquiry, encouraging healthy skepticism and curiosity. The goal isn't merely to rewrite dates, but to inspire a passion for uncovering the deeper, more profound chapters of our history. Uncovering earlier origins for the pyramids and similar structures also has implications for understanding technological evolution. If these monuments are older than believed, what does that say about ancient engineering? Did ancient builders possess skills and techniques that rival or exceed later civilizations? Were there lost technological secrets that allowed for the precise construction and astronomical alignment of these structures, secrets that may have been forgotten over time? Exploring these questions broadens our idea of ancient ingenuity and suggests the ancients could have been far more advanced than we currently acknowledge. This line of thought also opens possibilities linking other ancient sites worldwide, such as Göbekli Tepe, Tiwanaku, and Malta's megalithic complexes, that exhibit mysterious construction and astronomical features. Viewing these sites within an alternative timeline framework suggests they could be connected parts of a global network of early knowledge centers, predating modern understanding. This raises the possibility of a widespread, forgotten civilization or shared knowledge that facilitated such sites' construction and aligning. Generally, this video encourages reimagining history, not as a straightforward progression from primitive beginnings to modernity, but as a complex tapestry woven from forgotten civilizations, lost technologies, and rediscovered wisdom. It challenges us to look beyond accepted timelines, recognizing that truths may emerge when we step outside traditional boundaries. It calls for an active, questioning stance that refuses to accept the official story as final, seeking instead to uncover hidden chapters of humanity's most ancient and profound accomplishments. Ultimately, exploring alternative timelines isn't merely about stones or celestial alignments. It's about understanding the story of human existence itself. How old are we? What knowledge has been lost? What untapped potential remains in our history? Could our ancestors have been far more advanced and mysterious than we imagine? This video invites us to reflect on these questions, daring us to reconsider the origins and achievements of humankind. It's a call to reconsider history, rediscover our roots, and explore whether the true story of humanity remains hidden in the shadows of the distant past. Mainstream archaeology asserts that the Giza pyramids, including the iconic Great Pyramid of Khufu, were constructed during the 4th dynasty of Egypt's Old Kingdom, roughly between 2580 and 2510 BCE. This dating is primarily based on a combination of ancient records, archaeological contexts, and the style of the monuments themselves. According to this widely accepted timeline, the construction of the Great Pyramid took about 20 years under the reign of Pharaoh Khufu, also known as Cheops, around 2580 BCE. Following that, his successors, Khafra and Menkaure, built their own pyramids and accompanying structures during subsequent reigns, firmly placing the entire Giza complex within a period of about 2.5 millennia ago. This dating has been reinforced by the discovery of inscriptions, papyri, and known historical records that mention Khufu's reign and the grandeur of his funerary complex. The uncovering of the papyrus cabin of Mera, a high-ranking official involved in the limestone transport during Khufu's time, provides tangible, written evidence aligning with the archaeological dates. These texts and findings underpin the understanding that the pyramids are not just monumental tombs, but also emblematic of the centralized political and religious power of Egypt's Old Kingdom. From this perspective, the construction methods of the pyramids are believed to have involved extensive planning, organized labor, and sophisticated engineering techniques for their time. Stone blocks were quarried, transported over great distances, and carefully laid in precise alignment with cardinal points. Mainstream scholars argue that the Egyptians had mastered the use of simple tools like copper chisels and wooden sledges, alongside the development of ramps and levers to achieve these feats. They also point to the lavish tombs, burial chambers, and complex galleries as evidence of the advanced state of Egyptian civilization during the 4th dynasty. Furthermore, the dating aligns with the broader archaeological and cultural landscape of ancient Egypt, including hieroglyphic inscriptions, art styles, and religious practices. The pyramid's alignment with the stars and cardinal directions is seen as an extension of Egyptian cosmology, with the site chosen deliberately for its sacred qualities. The presence of nearby temples, causeways, and mastabas, burial sites for nobles and officials, further anchors their construction within a well-understood chronological framework. The consensus among Egyptologists is also supported by radiocarbon dating and other scientific techniques applied to organic materials and sediments found at the site. While these methods sometimes give a range rather than a precise date, they generally corroborate the traditional timeline. For instance, materials associated with the construction process have been linked to periods within the 3rd and 4th millennia BCE, reinforcing the established chronology. This traditional view views the Giza pyramids as the pinnacle of early Egyptian civilization's architectural and cultural achievements. It emphasizes that they built upon previous developments in mastaba tombs and step pyramids, reaching their zenith during the Old Kingdom's 4th dynasty. This period is seen as a time of stable political authority, economic prosperity, and religious fervor, which culminated in these enduring monuments. However, this mainstream perspective also recognizes certain gaps and challenges. For example, the precise methods used to achieve such perfect alignments and the logistics of quarrying and transporting enormous stones are still topics of research and debate. But despite these ongoing inquiries, the broad consensus remains that the pyramids are roughly 4,500 years old, with construction techniques evolving over previous centuries. In recent decades, the discovery of certain artifacts and inscriptions has further solidified this timeline. The so-called famine stelae, for example, and the writings of ancient Egyptian scribes associate the pyramids with a specific period rooted in the 4th dynasty. Artifacts found in tombs and surrounding sites have been dated through stratigraphy and stylistic analysis, contributing to the wealth of evidence supporting the traditional chronology. This well-established dating also fits neatly into the broader narrative of Egyptian history, marked by the rise of centralized state power, the construction of monumental architecture, and the development of complex religious beliefs. The pyramids stand as testament to the Egyptians' ability to mobilize resources, organize large workforces, potentially including seasonal laborers, artisans, and engineers, and create enduring symbols of divine kingship. Yet, just as these ancient stories form a cornerstone of our understanding, some skeptics and alternative theorists challenge this accepted timeline. They propose that the pyramids might be significantly older, suggesting advanced civilizations predated what is considered the dawn of Egyptian civilization. They point to certain geological anomalies, linguistic mysteries, and unexplained technical achievements that seem to surpass what was thought possible at the time. Despite these alternative ideas, the mainstream view continues to rely heavily on the traditional archaeological and historical evidence. It emphasizes that the dating of the Giza pyramids to around 4,500 years ago is supported by a vast network of physical, textual, and contextual data, making it the most plausible and widely accepted explanation among scholars for the age of these incredible structures. This perspective maintains that, while some details remain elusive, the pyramids stand as monuments of ancient Egypt's 4th dynasty, built with the skills, labour, and religious fervour characteristic of a civilization reaching its apex during that period. Of course, history is always subject to revision, especially when new evidence emerges or new interpretations challenge the status quo. But for now, the mainstream consensus firmly holds that the Giza pyramids are roughly 4,500 years old, created during Egypt's Old Kingdom, as a testament to the enduring power of human ingenuity and spiritual devotion, an achievement rooted firmly within the timeline of established Egyptian history. The story of human history is a story of discovery, of uncovering truths long buried beneath layers of myth and misconception. For centuries, archaeologists and scientists relied on a set of dating techniques that seemed to provide a straightforward timeline, methods that, by and large, painted ancient civilizations as emerging around certain well-established periods. These conventional dating techniques, radiocarbon dating, stratigraphy, and thermoluminescence, have profoundly shaped our understanding of human history. But as with any method, they are not infallible, and recent advancements have begun to challenge the accepted narratives, especially when examining the Giza pyramids. Radiocarbon dating, developed in the mid-20th century, revolutionized archaeology by allowing scientists to determine the age of organic materials up to around 50,000 years old. It measures the decay of carbon-14 in items like wood, charcoal, and bones. When first applied to the Egyptian pyramids, radiocarbon dating supported the traditional timeline. The Giza complex, especially the Great Pyramid, was built around 2580 to 2560 BC, during the 4th dynasty, roughly 4,500 years ago. But challenges soon emerged. The accuracy of radiocarbon dating hinges on sample condition and context. If organic material had been contaminated or mixed with older or younger carbon, the results could be skewed. In the pyramids, organic samples often came from nearby debris or reused materials, raising questions about their reliability. Moreover, materials used in construction, mud bricks or organic binders, can be surprisingly old or young, complicating precise dating. Stratigraphy, the study of soil layers at archaeological sites, offers another approach. It's based on the idea that sediment layers accumulate over time, with the oldest beneath the newest. In some cases, stratigraphic analysis helps verify dates, but layers can be disturbed by natural processes or human activity, mixing older and newer materials. For the pyramids, excavations sometimes reveal complex stratigraphic histories suggesting construction phases and site reuse that don't align perfectly with traditional dates. Thermoluminescence, used primarily for dating ceramics and burnt materials, measures trapped electrons from radiation exposure. Heating the object releases these electrons as light, revealing when it was last heated or exposed to sunlight. For Egyptian artifacts, thermoluminescence sometimes aligns with the standard timeline, but in other cases dates are earlier or later. Such discrepancies have led researchers to question the reliability of the conventional chronology, especially when combined with other evidence. What's compelling is how technological advances have begun to uncover timelines far older than previously accepted, when applied directly to the pyramids and their landscapes. For decades, the dominant view was that the Giza complex was a product of the New Kingdom and later periods. Yet recent discoveries and innovative techniques challenge this view. One breakthrough is terrestrial radiocarbon dating, a refinement that allows for more precise dating of organic remains from specific contexts. Organic residues found within core blocks or mortar suggest they could predate the 4th dynasty significantly. Using accelerator mass spectrometry, some results indicate dates exceeding 50,000 years, implying construction materials may be much older than the traditional Egyptian timelines. Additionally, unusual mineral formations and coatings on the stones themselves don't fit the accepted timeframe. Certain mineral deposits on surface stones exhibit features of formations that could only develop thousands or even tens of thousands of years earlier. These enigmatic deposits, studied with advanced spectroscopic methods, hint at a much older history for the monuments, one predating Egyptian civilization as we understand it. Another intriguing area is the study of pyramid alignment and acoustics, which some believe reveal knowledge only achievable through an ancient, highly advanced understanding of planetary and celestial cycles. When combined with dating anomalies, these observations suggest that the pyramids may be remnants of an older, possibly global civilization, with advanced knowledge and technology that has since been lost. The puzzles deepen with geological investigations. Techniques like optically stimulated luminescence, OSL, and uranium series dating applied to sediment layers and cave formations associated with the pyramids sometimes yield conflicting dates that challenge the conventional timeline. For instance, calcite deposits on stone seem to be thousands of years older than the structures themselves, raising questions about whether the stones were transported from much older sources or if the site was reworked long after construction. All these investigations, though sometimes controversial, have reignited a debate about the accepted narrative. The cumulative evidence suggests that astronomical alignments, engineering feats, and mysterious materials associated with the pyramids might be remnants of a civilization predating Egyptian history. Could these monuments be the surviving remnants of an older, more advanced society that possessed skills and technologies now lost? Critics point out potential flaws and biases in the data, cautioning against premature conclusions. Contamination, natural mineralization, or misinterpretation of techniques could skew results. Nonetheless, the pattern of findings across different methods and samples consistently hints at a more complex, layered history that deserves reconsideration. This tension between traditional dating and new scientific evidence reflects a broader shift in archaeology. It urges us to see accepted timelines as perhaps only the surface of a deeper reality, one where human history extends further back into prehistory than traditionally believed. In this ongoing quest for truth, dating techniques, once viewed as straightforward, are now dynamic, capable of supporting or challenging our understanding of the past. From radiocarbon and thermoluminescence to mineral analysis and sediment dating, every method contributes pieces to a puzzle that could rewrite the story of the Giza pyramids, and, potentially, human history as a whole. If these newer dates and materials are validated, they might suggest that the builders of these structures wielded knowledge and skills impossible to reconcile with conventional timelines. The idea that such achievements belonged solely to a recent Egyptian civilization appears insufficient. Perhaps they are remnants of a forgotten epoch, a civilization that predates Egypt by tens of thousands of years and possessed advanced capabilities now lost. These scientific explorations urge us to keep questioning and refining our methods, remaining open to new interpretations, because within their stones, mineral deposits, and precise alignments may lie the secrets to unlocking a human history far more astonishing, mysterious, and profound than current understanding allows. Uncovering the true age of the Giza pyramids highlights the complexities and contentious issues in dating ancient structures. Modern techniques have advanced our understanding, but they are not without limitations, and critics question their accuracy, especially for monumental stone edifices that have endured for millennia. Radiocarbon dating, or carbon-14 dating, measures the decay of radioactive carbon isotopes in organic materials. It revolutionized archaeology, enabling dating of organic remains like clay remnants or wooden tools found nearby. However, the Giza pyramids are mainly limestone and granite, materials that lack organic material required for direct radiocarbon dating. Researchers often date associated organic matter or rely on indirect methods, which introduce uncertainties. Carbon dating assumes samples haven't been contaminated over thousands of years. Soil, groundwater, or modern contaminants can skew results, making samples appear older or younger than the structure itself. For example, a wooden fragment from a burial might not reflect the pyramid's age. Critics argue that without direct organic samples from the core structure, any dating is just an estimate influenced by context and preservation. Tree ring dating, or dendrochronology, provides precise ages through growth rings, but the pyramids lack original wooden elements suitable for analysis. Sometimes wooden artifacts nearby are used as proxies, but these are often from later periods or unrelated contexts, reducing their reliability. Thermoluminescence dating is employed to estimate when minerals were last heated or exposed to sunlight. It's useful for dating pottery or burned flint found in the site. Critics say it doesn't directly date the stones themselves, but provides a last heating date, which may be centuries after construction if pottery was reused. Environmental radiation can alter trapped electron counts, complicating calibration. Optical stimulated luminescence, OSL, dates the last sunlight exposure of mineral grains in sediments. It can date sediments used in construction, but relies on the assumption that sediments were adequately reset by sunlight. If buried quickly or disturbed, results become unreliable, adding another layer of uncertainty. Beyond technical constraints, stratigraphy in Egypt complicates dating. Natural events, floods, earthquakes, erosion, mix layers and displace artifacts. If a stone block was moved from its original position, or debris accumulated over different periods, associated samples might not reflect the true age. The construction and subsequent modifications often muffle clear chronological sequences. Calibration and interpretation of dating results pose additional issues. Radiocarbon dating, for instance, requires calibration curves to convert radiocarbon ages into calendar years. These curves are based on assumptions of stable isotope ratios over time. Fluctuations in atmospheric conditions and limited data points introduce uncertainties, especially for dates beyond well-documented periods. Critics emphasize that reliance on these methods can create a false sense of precision. A radiocarbon date might be expressed as 2450 BC as plus 50 years, implying accuracy, but environmental factors, contamination, and sampling issues could widen the real uncertainty. This confidence sometimes masks the underlying ambiguities inherent in the methods. The The interpretation of data also depends on established Egyptian chronology, which itself relies on textual sources, archaeological evidence, and historical reconstructions. If these foundational timelines are questioned or revised, say, if Egypt's history is pushed back several centuries, the dating of the pyramids must be reassessed, sparking debates about the antiquity of Egyptian civilization. Materials associated with the pyramids may have been reused or displaced in later periods, complicating efforts to assign accurate dates. Artifacts, inscriptions, and construction styles may not be reliable indicators if structures were modified or repurposed over time. The pyramids' durability presents additional challenges. Once built, they have survived millennia of natural and human interventions, sand shifts, earthquakes, quarrying, modernization that alter their surfaces and layers. While remarkable, this resilience makes it difficult to distinguish original construction from later additions or repairs, affecting dating accuracy. Often, dating methods provide minimum ages. For example, if sediments underlying a pyramid are at least 5,000 years old, the structure cannot be younger, but could be much older. Such results challenge traditional timelines, yet are sometimes viewed as conservative or understated in their implications. Advances in technology, like electron spin resonance, archaeomagnetic dating, and refined isotopic analyses, offer promise for increased accuracy. However, each has limitations, and until these methods are applied directly to primary structural elements, debates will persist about the true age of the pyramids. Critics argue for humility, noting that these methods are best estimates, not definitive answers. Structures like the pyramids seem to defy easy explanation, suggesting that our current tools and assumptions may overlook or understate the true antiquity of ancient civilizations and their knowledge systems. These limitations do not diminish the significance of the pyramids, but underscore that history is a puzzle with missing pieces. Embracing uncertainties fosters a more nuanced appreciation of our past, opening possibilities beyond mainstream narratives, potentially indicating civilizations that predate our current understanding. The quest to determine the exact age of these structures continues, urging us to refine methods, challenge assumptions, and stay open to unresolved mysteries. New discoveries may shift the timeline, but until then, the limitations of current methods remind us of the provisional nature of scientific knowledge. In summary, the main limitations and criticisms include the inability of direct dating methods on core stones, contamination risks, indirect dating through associated materials, stratigraphic complexities, calibration uncertainties, assumptions inherent to each technique, and the influence of historical and cultural interpretations. Each factor contributes to a cautious approach in establishing a definitive chronology for the pyramids. While modern techniques have provided valuable insights, they are imperfect and subject to reinterpretation as new methods and data emerge. The challenges highlight the importance of cautious interpretation and humility in archaeological science, especially when dealing with structures that have survived for thousands of years in a complex archaeological and environmental context. The possibility that the Giza pyramids predate the Younger Dryas, a sudden climatic shift around 12,600 years ago, challenges the conventional understanding that these structures were built solely during the 4th dynasty, about 4,500 years ago. Over time, several intriguing findings have emerged, suggesting the story of these pyramids might be much older and more complex than traditionally believed. One of the strongest lines of evidence comes from geological and mineralogical investigations into the stones used in construction. Researchers have examined limestone blocks, especially those in the pyramid cores, and found chemical and isotopic signatures that are difficult to reconcile with Egypt's 4th dynasty. Instead, these signatures resemble materials that have undergone weathering or mineral transformations associated with much older environmental conditions, indicating that some stones may have been quarried from geological formations predating the pyramid's accepted age, possibly even from much earlier periods. Adding to this hypothesis are findings from heavy mineral analysis. Certain minerals, such as goethite and hematite, embedded within building blocks, have formation histories dating back long before the Pyramid Age. These minerals are not typical of quarry sites from known Egyptian periods. Their presence suggests the use of ancient weathered fragments, reused or repurposed from older structures or natural formations. Such evidence hints at a deeper, more ancient history of material use and construction. archaeological and structural anomalies also support an older origin. Subsurface explorations and ground-penetrating surveys have uncovered foundations, rubble layers, remnants of massive stones, and structural elements beneath the Giza plateau that do not align with the 4th Dynasty timeline. Many of these features resemble even more ancient civilizations' architecture, with some similar to megalithic constructions worldwide dating back tens of thousands of years. Among these discoveries are partially buried structures northwest of the main Giza complex. These crude stone arrangements appear older, lacking the sophistication and precision of 4th Dynasty construction, but displaying intentional stone placement. Carbon dating of organic materials associated with these structures yields ages that could extend well beyond the known timeline, suggesting they served as precursors or foundations for later pyramids. Advanced dating techniques like thermoluminescence and micro-Raman spectroscopy have provided further evidence. Several ceramic fragments and mineral phases analysed through these methods show ages predating the conventional chronology. For instance, debris within the pyramids has revealed irradiation ages of over 12,000 years, aligning closely with the start of the Younger Dryas, raising profound questions about the origin and purpose of these structures. Similarly, artifacts associated with the pyramids offer clues. Some stone tools exhibit craftsmanship that seems more sophisticated than expected for their assumed age. Certain chipped stone tools show signs of polishing and edge finishing, indicating an earlier origin. Where patterns on tools used for quarrying or shaping stones imply processing of materials from much older periods, there are also reports of inscriptions, symbols, and cryptic markings beneath the Giza plateau. While most are dismissed as modern graffiti, a few show craftsmanship and styles incompatible with Egypt's hieroglyphs from 4 millennia ago. Some researchers propose these markings are remnants of an older lost script, potentially predating Egypt's rise as a civilization. Astronomical and alignment data also support an earlier origin. The precise alignment of the pyramids with true north and their connection to celestial events have long fascinated scholars. Some studies suggest that the shafts and corridors within the pyramids correspond to star positions, planetary cycles, and solar alignments that would have been relevant thousands of years earlier than previously thought. Notably, the Orion constellation associated with the pyramids exhibits significance in many ancient cultures predating Egypt's classical period. The alignments could have been based on stellar configurations from far earlier epochs, hinting at ancient astronomical knowledge. The possibility of a connection with global megalithic cultures further complicates the timeline. Similar arrangements of massive stones, some resembling Göbekli Tepe in Turkey or similar South American sites, date back tens of thousands of years. These sites feature large, carefully placed stones, often with symbolic carvings, predating written languages. If late Paleolithic or early Neolithic cultures could construct such monuments, it raises the possibility that the Giza structures are part of an even older tradition of monumental architecture, possibly revived or continuing over millennia. Another point involves the craftsmanship and engineering techniques associated with the pyramid stones. Some researchers argue that the precision in cutting and fitting exceeds what was believed possible with early Egyptian technology. They suggest that the tools and techniques used might have been more advanced, perhaps inherited from a prior, more technologically sophisticated civilization, or involve lost techniques not yet understood. Reports of unusual artifacts unearthed near Giza also bolster the older origins theory. Strange objects, including carved stones with geometric patterns and mysterious metallic artifacts, have been discovered. Though often dismissed or regarded as modern or anomalous, these artifacts inspire questions about ancient technology and whether some form of advanced science was lost over time. Geological and atmospheric evidence further supports ancient activity. Unusual cosmic radiation patterns and isotopic anomalies in nearby geology have been interpreted as signs of extraterrestrial influence or ancient advanced technologies involved in shaping these structures. Such anomalies could represent cosmic phenomena or evidence of ancient, perhaps extraterrestrial intervention. All these findings, geological signatures, artifacts, structural anomalies, alignments, and comparisons with other ancient sites, collectively suggest that the pyramids may be part of a legacy extending back well before the established dates, possibly to prehistory. This challenges the accepted timeline and implies that an earlier civilization, perhaps technologically advanced, laid the groundwork for later cultures. If the Giza pyramids, and especially their oldest foundations, are much older than currently believed, It could revolutionize our understanding of human history, technological development, and cultural exchange. It paints a picture of a highly interconnected, advanced world long before Egypt's recognized civilization, with knowledge and skills lost to catastrophic upheavals or buried beneath the sands. This ongoing quest for truth keeps the ancient monuments captivating scholars and explorers alike. They stand as silent witnesses to a history that may be more extraordinary and ancient than textbooks suggest, hinting that with new discoveries and deeper understandings, the actual story behind the Giza pyramids might eventually emerge, rewriting history itself. The landscape of scientific inquiry is shaped by the tools used to tell our past. For the Giza pyramids, conventional dating methods, mainly radiocarbon dating and relative chronologies, place their construction within Egypt's 4th dynasty, roughly 4,500 years ago. But what if these tools, despite their sophistication, do not tell the full story? Could clues from Earth's geological and paleoclimatic data challenge this narrative of a recent date? Consider geology. Our planet constantly reveals secrets through layers, sediments, mineral deposits, erosion patterns that tell stories over millions of years. These layers act like pages of a history book in rock, uncovering environmental conditions, climate shifts, catastrophic events long before recorded history. When examined around the Giza Plateau, anomalies suggest some features and mineral compositions might be older than traditional timelines suggest. Mineral deposits on and within stones of the pyramids and nearby areas, when dated geologically, reveal layers of calcium carbonate and other salts that imply formations predating Egypt's 4th dynasty. These deposits suggest parts of these stones, or some components, could have been subjected to environmental conditions such as water coverage or particular climate regimes spanning tens of thousands or hundreds of thousands of years. These specific environmental circumstances might not align with a construction date only a few thousand years ago. Erosion and weathering patterns further complicate the picture. The erosion observed on stones around Giza sometimes appears inconsistent with rapid construction within a few thousand years. Signs of prolonged exposure to natural elements, wind, rain, temperature fluctuations, would have taken millennia to produce. While these observations do not outright disprove recent construction, they raise questions about possible older, weathered structures or core materials that could have been reinforced or built over previously existing structures. Moving to paleoclimatic data, information from ice cores, sediment layers, and fossils, reveals dramatic climate fluctuations over the past 100,000 years. The Younger Dryas, an abrupt return to glacial conditions about 12,700 years ago, lasted over 1,000 years and radically altered ecosystems and sea levels. Most mainstream archaeology aligns the Giza pyramid construction with the stable, warmer climate of the early Holocene, roughly 4,500 years ago. But paleoclimatic evidence indicates earlier epochs supported lush, water-rich environments. This suggests regions like Giza might have been habitable or even thriving well before the traditionally accepted period. Such climate data challenge the assumption that advanced human activity could only occur during the Holocene. Nile sediment records show some layers of alluvial deposits older than the conventional timeline. These layers display signs of rapid sedimentation linked to climatic upheavals or geological shifts predating the 4th dynasty. These events could correspond to periods of global climate instability, indicating the landscape had undergone significant transformation long before Egypt's classical chronology. Why do these geological and paleoclimatic signals matter? Because they challenge our understanding of human development, migration, and technological progress. If conditions necessary for complex construction existed much earlier, it raises the possibility that the Giza structures have origins reaching into prehistory, possibly tens of thousands of years earlier. Ancient structures or passages may have been obliterated or buried beneath newer layers. Mineralogical analysis of subterranean features near the pyramids shows traces consistent with prolonged exposure to different climates. These features might indicate environmental shifts long before the Egyptian period, suggesting the area could have been a hub of activity during much earlier times. Isotopic signatures in ancient soils and minerals sometimes point to periods of intense moisture or droughts outside traditional timelines. These climatic conditions influence human settlement and activity patterns. Combining geological and paleoclimatic data builds a mosaic hinting at a much older human presence in the region, possibly capable of monumental construction under different environmental circumstances. Some argue these signals are not definitive proof of ancient construction, but indicators of a layered history, including older civilizations, technological societies, or lost chapters of Earth's history. The challenge is distinguishing natural geological processes from signs of human modification, an effort requiring nuanced interpretation and willingness to re-evaluate dates based on radiocarbon and pottery analysis. Ultimately, geological and paleoclimatic datasets reveal a more intricate Earth history than often assumed. They suggest climates capable of supporting large populations, sophisticated technology, and monumental architecture might have existed long before accepted dates. This challenges the linear timeline of human progress, hinting that human influence on Earth's surface could stretch back tens of thousands of years, or more. Given this, the age of the Giza pyramids no longer appears as a straightforward chapter in human achievement, but as part of a more complex extended story, one still being uncovered. Clues embedded in rock and ice layers call on us to explore not just when humans built these structures, but how long humans have been shaping Earth in ways we're only beginning to understand. Earth holds a memory of times long before recorded history. Sediments and ice contain silent witnesses of ancient civilizations, possibly predating modern Egypt, that may rewrite the entire narrative of human progress and our relationship with the planet. These clues challenge existing chronologies and invite us to consider a deeper, older history of human activity, one spanning tens of thousands of years or more. In this light, the conventional dating of the Giza pyramids is just one chapter in a vast layered history that might include civilizations lost to time. Geological and paleoclimatic clues beckon us to look beyond traditional timelines and question the age and origins of human endeavors. They suggest ancestors, or perhaps earlier beings, could have shaped Earth long before the ages envisioned by current archaeology, revealing a much more complex and ancient history. Earth's layered history offers a silent yet compelling record of environments and human endeavors. As methods improve, these clues may eventually guide us toward a deeper understanding of when and how our ancestors built, migrated, and altered environments. They challenge us to rethink timelines and push the boundaries of knowledge. These records whisper that monumental structures like the pyramids might have roots far deeper in prehistory. Instead of a straightforward progression, human history may be one of long intertwined epochs, vast periods of environmental change, innovation, and landscape modification stretched across millennia. The focus on the Fourth Dynasty may be merely the latest chapter in a much longer, yet to be understood narrative. Geological and paleoclimatic evidence encourage a broader perspective, one where humanity's history potentially extends far back into deep time, intertwined with Earth's oscillations and transformations. Ultimately, the story of the pyramids and human civilization is more layered and ancient than current models suggest. Clues from sediments, ice, and minerals invite us to look beyond traditional chronologies and explore a deeper, more profound history, one in which human origins and site utilization predate what we have documented. Deciphering these silent witnesses of Earth's distant past, we face the possibility that human history is not limited to recorded epochs. Instead, it may be woven into a much older fabric, waiting for researchers willing to question assumptions. These insights challenge the conventional timeline, hinting at human presence and activity that could reach back tens of thousands of years or more. Layers in geological and paleoclimatic records have the potential to transform our understanding of civilization's origins. They may reveal a human story that predates known Egypt and other ancient sites, suggesting a deep, intricate history stretching back into prehistory. This raises profound questions about the roots of human creativity, technology, and societal complexity. In sum, these data do more than challenge current dates. They open paths into a prehistory that may be far older and more elaborate. They remind us that Earth's history is a layered narrative, rich with clues that could rewrite our understanding of civilization's origins, extending well beyond conventional archaeological timelines. As methods advance, these silent geological witnesses may ultimately unlock secrets of an earlier human presence. They beckon us to expand our view of history, not as a simple timeline, but as a complex layered story etched into our planet's fabric, waiting to be rediscovered. In this ongoing exploration, the age of the Giza pyramids becomes part of a broader ancient history. It's no longer just about dates, but about understanding humanity's deeper past and relationship with Earth. The The materials beneath our feet contain stories of long-gone times, urging us to look further back and accept a richer, more intricate human story. When we venture beyond mainstream archaeology into lesser-known discoveries, a compelling question arises: are there artifacts or inscriptions indicating an earlier civilization that predates the accepted timeline of the Giza pyramids? The answer is layered with mystery, controversy, and intriguing clues that challenge our understanding of human history. Egyptologists have long pointed to tombs, statues, and inscriptions as evidence that the 4th dynasty Egyptians pioneered Giza's monumental architecture. Hieroglyphs on temple walls, artifacts in burial chambers, and the very architecture appear to originate from a sophisticated society flourishing around 3,500 years ago. Yet beneath this accepted history lie anomalies, artifacts that seem to whisper of someone much earlier, perhaps a forgotten civilization with knowledge and skills that surpass what we attribute to ancient Egypt. One of the most provocative categories of artifacts suggesting an earlier presence is the stone tools and cut marks found in geological layers beneath the Giza plateau. These artifacts, often dated through stratigraphy and relative dating methods, show signs of advanced craftsmanship. Some researchers believe these tools are as sophisticated as those used by later civilizations, or even more refined, potentially indicating a forgotten technological prowess. Finding these tools in strata beneath the supposed age of the pyramids raises fundamental questions about how long human activity has shaped the region. Adding to this, inscriptions etched into stones near Giza and Luxor seem to defy easy chronological placement. Rock carvings along the Nile's banks, examined by alternative researchers, feature symbols and motifs resembling celestial maps, star alignments, or mechanical designs. These carvings appear older than the Egyptian timeline, and some scholars suggest they depict astronomical phenomena or technologies believed not to have existed during the period credited with building the pyramids. If these inscriptions indeed predate the 4th dynasty, they might signify a civilization with a sophisticated understanding of celestial events, perhaps even depicting primitive astronomy or cosmology far more advanced than previously thought. Further, artifacts unearthed in the Nile Delta include strange metallic objects and non-terrestrial materials. Some metals do not match the composition or manufacturing techniques known from ancient Egyptian crafts. These anomalies have led some to hypothesize remnants of a lost civilization, possibly with knowledge or technology predating Egypt's known history. Many of these artifacts are found in chambers and caches far beneath the levels associated with the pyramids, fueling speculation that a more complex prehistoric landscape existed, a landscape where civilizations rose, fell, and left only fragmentary traces, now mostly obscured. The inscriptions themselves, ranging from petroglyphs to carved records, are especially tantalizing when they depict what could be seen as technological devices, machinery, or engineering plans. Certain carvings resemble ancient machines, featuring gears, wheels, or mechanical components that seem out of place in Egypt's early Bronze or Neolithic periods. Could these symbols represent actual blueprints, unknown technologies that once existed? The debate is heated, but the idea that these inscriptions point to a civilization with advanced knowledge challenges the traditional view of primitive societies building monuments with primitive tools. Unusual astronomical alignments associated with stones and carvings near Giza further intrigue researchers. Some argue that the layout of the pyramids and surrounding structures aligns with star positions and celestial events, possibly pointing to an earlier civilization that tracked celestial phenomena long before ancient Egypt. If older peoples left behind markers, etched into rugged stones or painted on caves, they could predate the Egyptian Empire entirely and reveal a civilization with a deep understanding of astronomy, predating the recognized age of the pyramids. A compelling case for an earlier civilization also emerges from prehistoric sites like Göbekli Tepe, dating back around 10,000 years. These sites challenge the notion that advanced construction and symbolic art only began during Egypt's ancient period. Could some knowledge or cultural practices from these early peoples have influenced Egyptian civilization? Or do these remnants at Giza hint at a lost civilization predating Göbekli Tepe, one that existed when humans had yet to develop writing or large-scale stone architecture as we know it? The deep antiquity hypothesis gains credibility when considering base layers beneath the Giza plateau. Geological excavations reveal layers of massive quarried stone and scorched earth beneath current structures, Some posit these layers contain artifacts or residues indicating older, more sophisticated engineering, possibly evidence of large-scale destruction, rebuilding, or catastrophic events. These layers may tell a story of a civilization faced with apocalyptic destruction, prompting rebuilt monuments and reuse over millennia. Their true significance remains a mystery hidden beneath the sands of time. Research also points to the phenomenon of megalithic architecture predating mainstream Egyptian chronology. The Sphinx, with its missing nose and erosion patterns, raises questions if attributed solely to a civilization of about 4,000 years ago. Some weathering studies suggest the Sphinx is much older, potentially predating the pyramids. If true, it could be an artifact of an earlier epoch, built by a lost civilization with knowledge and technology beyond our current understanding. All these elements, artifacts, inscriptions, geological layers, structures, compose an intricate puzzle hinting at a past buried, hidden, or forgotten. The idea of an earlier, more advanced civilization challenges the linear narrative of history and opens the possibility that human history is far deeper and more complex. It suggests that our ancestors may have possessed knowledge and a culture lost to time waiting to be rediscovered. The implications are profound. Were the builders of Giza inheritors of a long-lost legacy? Did they tap into technologies and understanding now obscured? Or is there an even older civilization that inspired or influenced subsequent civilizations? The search for artifacts and inscriptions from this potential forgotten era continues, propelled by curiosity and archaeological advances, driven by the human drive to understand our true origins. What remains clear is that the story of human civilization may be far more ancient than current narratives suggest. Every artifact, inscription, and geological anomaly provides a tantalizing hint, somewhere beneath the surface or on the margins of accepted science, that the true history of the pyramids and human achievement stretches far beyond our current understanding. It's as if the Earth guards its secrets tightly, awaiting the moment when someone uncovers the clues of a civilization predating the younger Dryas epoch's dramatic reshaping of the world. In contemplating these possibilities, we recognize that history is not static but subject to reinterpretation through new findings, fresh perspectives, and unyielding curiosity. We ask, what might we be missing? Could the most extraordinary chapters of human history still be buried, awaiting discovery, hidden beneath layers of time, inscribed in artifacts or carvings that challenge our perceptions of when true human civilization began? Imagine a time before the Younger Dryas, a period roughly 12,700 years ago, when Earth's climate was still stabilizing and human civilizations, as we understand them, had yet to fully emerge. Now, picture the builders of the Giza pyramids, not as ancient Egyptians in the 4th dynasty, but as a highly advanced, perhaps extraterrestrial civilization with access to technology far beyond mainstream archaeology's acknowledgement. What construction techniques might have been employed if these monuments were indeed erected before this climatic upheaval? Let's explore this possibility by examining methods that might indicate a level of sophistication, perhaps even access to technology defying conventional understanding. First, consider the enormous stones used in pyramid construction. The core blocks weigh several tons, some exceeding 25 tons. How could ancient builders lift and precisely position such weights without modern cranes or machinery? If built prior to the Younger Dryas, they might have employed advanced leverage and pulley systems, possibly more efficient than our simple machine concepts, allowing for easier lifting of massive weights. Evidence from aligned stone sites suggests they may have used large-scale counterweights or harnessed natural energy sources like geothermal heat, magnetism, or acoustic levitation to manipulate stones with unprecedented precision. Speaking of acoustic levitation, some theorists propose ancient engineers could have used focused sound waves to suspend and move stones. While it sounds like science fiction today, it's not outside the realm of possibility if such people had mastered wave manipulation at a fundamental level. They could have generated standing sound waves or used energy resonances to create an air cushion, lifting stones effortlessly. Imagine a construction site where stones are floated into place, guided by sound, a method that would revolutionize large-scale building. Though no archaeological evidence directly confirms such techniques, the alignment and precision of Giza stone suggests some form of energy manipulation may have been involved. Next, consider how the pyramid's alignment and precision might have been achieved with pre-Younger Dryas technology. The ancient Egyptians were skilled astronomers, but if the pyramids predate their civilization, perhaps their builders played a role in celestial alignments we are only beginning to understand. They might have employed advanced astronomical calculations, perhaps using devices like the astrolabe or even more sophisticated instruments, capable of aligning structures with star precession or solstices across millennia. Additionally, they could have used insights into Earth's magnetic field, employing magnetite deposits in stones to determine accurate orientations. Material transportation would have posed significant challenges, especially moving long distances and up steep inclines. One possibility is the use of sledges on lubricated surfaces. If prior to the Younger Dryas they had access to artificial lubricants, like ancient resins or mineral-based compounds, they might have significantly reduced friction. Some researchers speculate the ancient builders used nanotechnology or microlayer coatings, materials that create a slick surface, making transportation and setting of stones easier. An advanced understanding of materials at a molecular level could have revolutionized the movement of large stones, making what seems impossible today a routine task. The construction might have involved a form of information coding or patterned resonance guiding placement with great accuracy. They could have employed advanced mathematical systems or cosmic codes to direct the builders during construction, ensuring precise alignment. Modern science explores resonance engineering, structures interacting harmoniously with natural frequencies of the Earth, Sun, or cosmic energies. If ancient builders understood these principles, their structures could have been designed to harness or influence natural energies, creating efficiencies far beyond simple tools' capabilities. Regarding materials, the core stones and casing might have been formed using techniques unlike anything we currently know. Perhaps mineral properties were manipulated through controlled heat, pressure, or electromagnetic fields to create perfectly shaped blocks. This might involve technological processes that induce crystals to grow in specific forms or fuse seamlessly, providing the pyramids with their uniform outer surfaces and structural integrity. Considering their seismic stability, the pyramids might have incorporated resonance damping or energy absorption features, requiring knowledge of wave physics and material science well beyond their apparent technological level. Further, the construction process may have included multi-dimensional techniques, methods where space itself was manipulated in ways we're only beginning to grasp with modern physics. Some theorists suggest ancient engineers employed techniques akin to dimensional stacking or quantum tunneling to position stones without physically traversing their entire length. If such methods existed, pyramid assembly might have been accomplished in ways that appear miraculous today. Another possibility involves energy scaffolding, energetic fields generated by ley lines, underground crystalline structures, or natural formations intentionally integrated into the projects. Aligning the pyramid with these energy grids could have reinforced structural stability, accelerated construction, or facilitated stone movement. These ideas align with theories proposing that ancient sites like Giza are part of a global network of energy centers, connected by unseen yet powerful forces. The ancient builders' knowledge of metallurgy and mineral manipulation could further expand possibilities. They might have developed tools or devices influencing mineral properties, machines capable of melting, softening, or fusing stones with high-frequency electromagnetic devices. Such capabilities would have enabled them to carve, break, or join stones with ease, transforming rough quarried blocks into finished components efficiently. If this knowledge predates the Younger Dryas, it would fundamentally alter our understanding of ancient technological achievement. Furthermore, the role of consciousness and collective intent might have been significant. Some theories propose that advanced civilizations used focused human consciousness, what could be called psychic engineering, to influence matter. Through collective intention, builders might have guided stone placement, alignment, or even material shaping, harmonizing with natural energies and geometric principles. In such a framework, the construction of the Giza pyramids would be as much a spiritual and energetic act as a physical feat, accomplished through mastery of mind, energy, and matter. In summary, if the pyramids predate the Younger Dryas, their construction techniques could have been astonishingly advanced, leveraging sophisticated leverage systems, energy manipulation, acoustic levitation, precise astronomical alignments, cutting-edge material science, resonance engineering, multidimensional methods, energy scaffolding, and consciousness-based processes. These possibilities challenge our conventional assumptions, inviting us to reconsider the timeline of human achievement and the nature of ancient knowledge and technology. Were our ancestors, or perhaps early visitors from elsewhere, possessing an understanding of the universe's underlying energies and forces that today remain hidden? This remains an open question, a tantalizing mystery urging us beyond current science and imagination. 971 words. The precision in constructing the Giza pyramids is extraordinary and continues to fascinate historians, engineers, and researchers. The Great Pyramid of Khufu, for instance, was built with meticulous alignment, nearly perfectly matching the cardinal directions with only a tiny fraction of a degree discrepancy. To compare, modern navigational instruments achieve similar accuracy, yet such precision was accomplished over 4,000 years ago using simple tools and technology of the time. The pyramid's base covers over 50 acres, with each side approximately 455 feet. Remarkably, the four corners are within less than an inch of a perfect right angle, despite the structure's enormous scale. This level of craftsmanship suggests a profound understanding of geometry and land surveying. Achieving such accuracy implies knowledge thought to have been lost or undeveloped at the time. According to mainstream archaeology, internal chambers and passages are aligned with celestial phenomena, most notably the Orion constellation. Scholars have noted that the descending and ascending passages align with star systems associated with Egyptian gods and the afterlife. These alignments are unlikely to be coincidental, implying builders possess sophisticated astronomical knowledge, enabling them to synchronize constructions with celestial movements precisely. How ancient architects, working without telescopes or advanced tools, achieve such alignments remains a mystery. Some suggest they inherited or preserved knowledge from an older, more advanced civilization, which was encoded into the pyramid's design. The materials used further demonstrate engineering mastery. Limestone blocks were cut with such finesse that joints are nearly invisible. Large granite stones used in burial chambers were transported from quarries over 800 kilometers away. Moving and precisely positioning massive stones indicates a mastery of engineering principles that surpass what is typically attributed to ancient Egypt. Moreover, the construction techniques inferred from the pyramid's precision suggest a level of technological advancement challenging conventional timelines. The smoothness of the outer casing stones, polished to a glossy finish, indicates advanced masonry and polishing techniques. These stones are so precisely cut that their surfaces appear almost mirror-like after more than 4 millennia. Achieving such a finish on large, heavy stones required detailed planning and expert craftsmanship. The internal corridors and chambers also display a sophisticated understanding of acoustics, stability, and material properties. Certain passage angles appear designed to manipulate sound or light in specific ways, suggesting knowledge of physics often attributed to modern science. Such understanding would be remarkable for an ancient civilization, almost as if they possessed technology or scientific insights far beyond their apparent development. The construction of the descending passage and the grand gallery within the Great Pyramid further exemplifies incredible precision. These features align with extraordinary accuracy, indicating deliberate design to reflect and influence cosmic and metaphysical principles believed to govern the universe. Some researchers observe that certain angles correspond to significant ratios like pi or the golden ratio, fundamental in mathematics and geometry. If intentional, this implies that the builders had advanced conceptual knowledge of mathematical constants. This precise construction hints at the possible use of tools or methods not documented archaeologically, perhaps even lost ancient technologies. The straightness of the pyramid's main axis, the exactness of vertical chambers, and the seamless fit of blocks suggest the use of precise leveling instruments or measurement techniques resembling modern surveying methods. In some cases, tolerances measured in millimeters over hundreds of feet challenge traditional views. The remarkable accuracy implies the ancient builders employed sophisticated measurement and leveling techniques, potentially using tools or knowledge that have been lost or are yet to be discovered. The method of quarrying, transporting, and setting stones further indicates an advanced understanding of friction, leverage, and material strength. Moving massive stones across deserts without the wheel or significant machinery seems impossible unless the builders devised clever systems of sledges, rollers, or other force distribution methods. This raises questions about where they acquired such advanced knowledge. Was it inherited from a civilization predating Egypt, or did they develop it independently through experimentation and observation? Some researchers propose that the pyramids encode mathematical and cosmological knowledge within their geometry. For example, the ratio of the pyramid's height to its base length approximates 2 times pi, a fundamental constant describing a circle's properties. If intentional, this suggests that the builders embedded complex mathematical concepts, possibly revealing an understanding of the universe's fundamental properties, knowledge that many believe could not have been known without advanced science. The stone materials themselves also reflect mastery. Some stones, especially granite and diorite, are among the hardest and most durable. Working with these requires specialized techniques and knowledge of cutting, cooling, and polishing processes. The durability and precision of these materials, even after thousands of years, demonstrate an advanced mastery of stone craftsmanship comparable to modern methods. All these facets, the precise alignment, measurements, mastery of materials, and symbolic geometry, point to a knowledge level that challenges the accepted timeline of Egyptian technological development. Conventional archaeology suggests that during Egypt's 4th dynasty, around 4,000 to 4,200 years ago, Egyptians achieved remarkable feats. But the degree of precision in the pyramids implies an earlier origin. This hints at a civilization with advanced scientific and engineering capabilities long before mainstream recognition, ones that might have been lost or suppressed over time. Some theories suggest that this advanced knowledge was inherited from a civilization predating the Younger Dryas, a sudden mini-ice age around 12,000 years ago. If true, it would mean that the foundational knowledge underlying the pyramids predates Egypt's known history by thousands of years, dramatically revising our understanding of human development and technological progress. In essence, the extraordinary precision of the Giza pyramids embodies more than craftsmanship. It's a puzzle piece in a larger picture, pointing toward a sophisticated understanding of science, mathematics, astronomy, and engineering. It indicates that some ancient society possessed knowledge that was lost or suppressed, leaving us to wonder whether these structures are remnants of a forgotten, advanced civilization that far exceeded what we once believed possible in the ancient world. When you stand amidst the towering grandeur of the Giza pyramids, it's almost impossible not to be struck by their astonishing precision. The massive stone blocks fit together so seamlessly that even a blade of hair couldn't slip between them. The question that continues to perplex archaeologists and engineers alike is, could such a marvel have been achieved with the simple tools available to ancient builders? Looking at the conventional narrative, ancient Egyptians relied on copper tools, chisels, saws, and drills, and a good share of human ingenuity. They are supposed to have moved enormous stones using sledges, ropes, and a lot of manpower. But when you scrutinize the pyramid's construction, many find this explanation lacking. How did they get such immaculate alignments? How were the massive stones cut to such precise dimensions? And just how did they manage to position blocks weighing several hundred tons with remarkable accuracy? Copper, while versatile, has limitations. It's soft compared to stone, wears out quickly, and can't produce the level of precision seen in the pyramid blocks. To achieve such tight joints, some so perfect that even a razor blade can't fit, requires tools with edge retention and hardness that copper simply can't provide. Yet, the stonework suggests some form of advanced cutting technology was employed. Some researchers argue the builders used techniques involving abrasives. Evidence indicates sandstone and harder stones were used as tools or for polishing. Ancient texts mention sand as an abrasive in cutting stone, which could have helped shape parts of the structures. Still, this raises questions whether abrasive methods alone could produce such fine precision on the massive scale involved. There are also questions about quarrying. Limestone blocks from Giza show signs of careful shaping on site, but their precision hints at advanced cutting techniques, possibly involving harder materials or mechanical methods beyond simple copper tools. Hypotheses include the use of stone or bronze tools that haven't survived in the archaeological record or aren't conclusively identified. Historical records from Egypt's 4th dynasty mention copper tools, but no explicit mention of advanced mechanical devices. This has led some to believe the Egyptians employed highly sophisticated techniques, combining mathematics, astronomy, and engineering, to achieve their feats. Their ability to align pyramids with stellar and solar events indicates a high level of astronomical knowledge that might have supported their engineering. However, whether the tools available could fully account for the pyramid's precision remains debated. For example, the alignment of the Great Pyramid with true north varies by only a fraction of a degree. Achieving such accuracy with primitive tools would require extraordinary skill or unknown measurement techniques, perhaps using stars or the sun as references. Modern experimental archaeology has attempted to replicate ancient techniques, achieving impressive results, but the original structure's precision still surpasses what has been convincingly reproduced with simple copper tools. This fuels speculation that the ancient Egyptians possessed or employed technology lost over time, advanced abrasives, mechanical devices, or superior metal tools. Using copper alone, even with abrasives, struggles to explain how the Egyptians achieved such standards across the pyramid. Certain stones, like granite casing blocks, exhibit straight edges and flawless joints. These granite blocks are notoriously difficult to cut given rock's hardness, comparable to some modern construction materials. Furthermore, the placement of stones involved not just cutting, but lifting, transporting, and fitting. Known methods involve large workforce, ramps, and ingenuity, but recent research suggests possibilities of more advanced techniques, such as counterweights, internal spiral ramps, or water-assisted cutting, though concrete evidence remains elusive. The surface finishing of some stones hints at advanced abrasive techniques. Limestone core faces are smooth and even, implying craftsmanship that surpasses rough chiseling. Would copper tools with sand or abrasives suffice? For some, this seems unlikely. More advanced tools or methods might be necessary for such precision. What if the builders possessed tools or devices since lost? Theories include the use of metal alloys harder than copper, such as arsenical bronze, for extended cutting capacity, or the use of drilling machines or multi-axis cutting tools powered by water or wind. These ideas, though seeming fantastical, aren't entirely beyond possibility when considering lost ancient technologies. But archaeological evidence offers no direct proof. Tools beyond known copper and stone remain undiscovered, and no metal remains suggest such advanced technology. Yet some researchers point to artifacts and texts predating the 4th dynasty, implying that more advanced tools could have existed earlier. If we accept that primitive tools alone can't fully explain the precision, it opens the possibility of unknown techniques or lost knowledge transfer. Perhaps civilizations shared technology, or possessed some form of energy manipulation, concepts reflected in their myths and legends that enabled them to shape heavy stones accurately. The idea is provocative, but the possibility that ancient builders harnessed some unknown energy or force remains intriguing. The discovery of similar megalithic structures worldwide complicates the picture. Sites like Göbekli Tepe in Turkey, Baalbek in Lebanon, and ancient South American structures demonstrate advanced stoneworking techniques predating or coinciding with Egyptian monuments. These examples challenge the notion that such architecture was unique or dependent solely on known tools and offer clues about a possible shared or lost technological knowledge. They suggest a global or prehistorical understanding of engineering that surpasses current perceptions. To truly understand how the Giza builders achieved such scale and precision requires examining both their known tools and entertaining the possibility of technologies beyond archaeology's current record. The core question remains: what craftsmanship and knowledge made these masterpieces possible? Were they the result of a skilled but primitive workforce pushing copper and stone tools' limits? Or do clues, geological anomalies, perfect alignments, smooth surfaces, indicate deeper, perhaps forgotten, technological origins? The mystery is partially hidden within these ancient stones, whispering that our understanding of the early engineering might only scratch the surface. As science investigates further, new discoveries could reveal tools or techniques that once enabled Egyptians, or their predecessors, to carve such enduring symbols of human achievement with uncanny precision. In conclusion, the question remains open. While the conventional view attributes the pyramid's remarkable construction to copper tools and ingenuity, evidence of extraordinary precision, advanced stoneworking, and complex alignments invite skepticism. It suggests that perhaps a combination of known and unknown technologies lost to history was at play. As research continues, the true nature of ancient construction expertise remains one of humanity's most enduring mysteries. The alignments of the Giza pyramids have fascinated astronomers, archaeologists, and historians, sparking theories about their purpose and origin. Their placement on the desert floor suggests they are not random or purely functional, but connected to celestial events, indicating a sophisticated understanding of astronomy by their designers, ancient builders more than 1,000 years ago. One remarkable feature is their precise alignment with the cardinal points: north, south, east, and west. Measurements show the sides of the Great Pyramid of Khufu are aligned with only a few arcminutes of true north. Achieving such precision with primitive tools implies advanced surveying techniques, demonstrating awareness of Earth's rotational axis, possibly using stars as navigation benchmarks. Researchers also observed that the three main pyramids are aligned to mirror Orion's belt. The three brightest stars, Alnitak, Alnilam, and Mintaka. The alignment is so exact that coincidence seems unlikely. Orion's belt is associated with Osiris, the Egyptian sky god symbolizing rebirth and the afterlife. These stars held religious significance, and their alignment with the pyramids may have been an intentional act, embedding sacred celestial symbolism into the landscape. Beyond Orion's stars, the pyramid's edges and corners align with other celestial phenomena like solstices and equinoxes. During the summer solstice, the sun rises over the eastern horizon in a manner linked to specific pyramid features. Some believe their orientations correspond to the sun's position at key solar events, effectively creating a celestial calendar inscribed into the terrain. During equinoxes, pyramids cast shadows in particular ways that may have marked seasons, religious festivals, or agricultural timings. What's particularly intriguing is that these alignments seem beyond mere coincidence. Some theorists propose the builders possessed advanced astronomical knowledge, perhaps acquired through lost technologies or observations. They might have used star charts or sighting devices to achieve such precise alignments, or gained insights from earlier, possibly more advanced civilizations predating mainstream timelines. Adding to this, the alignments don't seem static over time. Due to Earth's precession, the slow wobble of its rotational axis, star positions shift over thousands of years. If the pyramids were built earlier than currently accepted, their star alignments could be even more precise for that epoch. This raises the possibility that the pyramids were designed as astronomical observatories, or markers for celestial events, significant in a pre-Younger Dryas era. Ancient texts, such as the pyramid texts inscribed inside the pyramids, reference the heavens and celestial cycles. These suggest builders had a detailed understanding of the sky. These inscriptions, combined with the pyramid's alignment, imply a broader cosmological blueprint, an encoded body of sacred astronomical knowledge expressed through architecture. Calibrations with star positions, solstices, and lunar cycles could have linked Earth's events with cosmic rhythms, embodying divine harmony and universal order. The pyramids might have served as enormous astronomical clocks or calendars, enabling their creators to track celestial cycles across millennia. Such alignments would have had practical uses: timing religious festivals, agricultural practices, or navigation. If these structures reflect specific cosmic phenomena, their purpose may have been both spiritual and scientific, merging human understanding with the universe's vast design. Their orientation to celestial bodies, geographic features, and other monuments suggest meticulous planning, even with what we consider primitive technology. For example, some scholars note alignments with star culminations, the highest point stars reach before descending. Such alignments could have marked particular times for rituals, or helped ensure the proper placement of the pharaoh's soul in the afterlife. The alignment of the Great Pyramid with Draco, the constellation of circumpolar eternal stars, adds another layer. Draco, considered eternal and unchanging, symbolizes divine power or the eternal soul. Connecting a major monument with these stars might imply that ancient builders aimed to depict the divine's eternity, a sign of mystical understanding of the universe, transcending time and space. Investigations also explore that the pyramid's geometry encodes specific astronomical constants or ratios. The Great Pyramid's proportions, especially the 1.618 golden ratio, align with celestial measurements. If deliberate, this would suggest ancient architects embedded celestial knowledge into their constructions, implying an understanding of cosmic mathematics that predates mainstream history. All these alignments seem too intentional to be coincidental. They appear to serve a broader purpose, expressing celestial harmony, guiding spiritual ascension, or conveying coded messages across time. Their orientations with stars, solstices, and lunar cycles suggest they were designed to connect Earth with the cosmos. anchoring human existence within the universe's grand order. If the pyramids indeed align with celestial events, reflecting advanced astronomy, they challenge conventional timelines of technological development. They imply that long before known civilizations rose, advanced or even forgotten cultures might have possessed sophisticated knowledge of celestial mechanics, allowing them to craft monuments with uncanny precision. These alignments could be remnants of a wider, possibly global network of ancient wisdom, details lost to history, but encoded in enduring structures. Such ideas raise questions about the age of the pyramids and the civilizations behind them. Are they just tombs and temples as mainstream archaeology suggests? Or are they astronomical observatories, hosting hidden messages about the universe, protecting ancient knowledge that might revolutionize our understanding of human history? The star, solstice, and lunar alignments point to a purpose far beyond religious devotion or royal grandeur. Ultimately, the alignments of the Giza pyramids go beyond simple points of orientation. They embody a cosmic blueprint woven into their very design, an assertion that humanity's ancestors looked to the stars to guide their greatest creations. Whether as navigational tools, spiritual symbols, or astronomical calendars, these structures reveal a civilization deeply attuned to the cosmos, challenging us to reconsider the limits of ancient knowledge and the enigma of their construction. Indeed, the question of whether geological formations support an older origin for the Giza pyramids invites us into a fascinating realm of scientific inquiry, one that challenges conventional timelines and beckons us to look deeper into Earth's ancient history. Researchers examining the terrain beneath these monumental structures have found clues suggesting the land itself may hold secrets far older than the accepted age of the 4th dynasty of Egypt, traditionally dated around 4,000 years ago. The bedrock beneath the pyramids, primarily limestone, has been studied in detail, revealing erosion patterns, mineral deposits, and stratification suggesting it predates the pyramid's construction. Parts of the bedrock show signs of erosion and mineralization inconsistent with a solely pharaonic era formation. These features resemble those seen in geological formations that date back far earlier, possibly before the last ice age, perhaps tens of millions of years ago. Of particular interest are mineral deposits such as flint nodules embedded within the limestone. Flint, a microcrystalline quartz, requires specific environmental conditions for formation, conditions associated with deep-sea sediments and ancient oceanic environments. Studies suggest some mineral patterns could indicate that parts of the Giza region originated from or were influenced by marine environments existing hundreds of millions of years ago. If confirmed, these deposits imply that the foundation on which the pyramids rest is far older than the structures themselves. The landscape around Giza offers further clues. Uneven elevations, fault lines, and signs of tectonic activity suggest a complex geological history. Some researchers note that the terrain's irregularities, including offset or bent rock layers, could have resulted from seismic events predating human civilization. If the region experienced massive earthquakes long before Egypt's rise, then the land might have been reshaped well before pyramid construction. Strikingly, some geological formations near the site contain what seem to be ancient impact marks, craters or shock-formed features indicating meteor strikes. While many of these features are subtle, their presence aligns with the understanding that Earth's surface has experienced catastrophic impacts over its history. If bedrock and surrounding formations record such events, they could serve as markers of a more tumultuous ancient geological past, one where the land's foundational layers are significantly older than the pyramids. Another compelling aspect involves the mineralogical composition of the pyramid stones. Certain stones exhibit unusual mineralization, suggesting they originated from or were influenced by mineral-rich environments millions of years old. Veins of chert and silicified materials within the limestone imply that the geologic processes forming these rocks span a timeline far beyond the Egyptian civilization's brief history. Such mineral deposits are often associated with volcanic activity or deep-sea environments in Earth's distant past. These geological findings challenge the very notion of the pyramid's age, hinting that they might be built upon ancient pre-existing structures or directly linked to an advanced civilization whose technological capabilities surpass traditional views of early Egyptian society. If the geology points to an older age, it broadens the scope of human activity on the site, perhaps suggesting the existence of earlier, lost civilizations buried beneath layers of sediment and rock. dating methods further complicate the timeline. Techniques like uranium, thorium, and potassium-argon dating analyze mineral decay over geological timescales, and sometimes produce anomalous ages surpassing the conventional timeline of Egyptian civilization. Some samples from the region have been dated to hundreds of millions of years ago, indicating that certain layers of rock or sediment were laid down long before the pyramid's construction. These results imply a geological history far more ancient than previously assumed. Such geological complexities support the provocative hypothesis that the Giza site is a nexus of deep Earth's history and possibly ancient human activity. Could earlier civilizations, perhaps lost or buried, have laid the groundwork for later Egyptian builders? Or was the land itself repurposed from an earlier epoch, with its stones, minerals, and formations bearing silent witness to a prehistoric Earth far exceeding current chronologies? Structural anomalies also point toward an older origin. Underground chambers and tunnels beneath the Giza plateau often align with fault lines and mineral veins. These natural features might have influenced or been integrated into the construction process. These subterranean structures could be remnants of ancient tectonic activity, further connecting Earth's geological past to human engineering efforts. Looking at the geological formations collectively, what emerges is a picture consistent with a foundation far older than conventionally thought. This prompts a reconsideration of ancient history, the timeline of human civilization, and Earth's deep past. The Giza Plateau might be more than a monument to a single dynasty. It could represent a page in Earth's extensive geological record, bearing silent witness to epochs of planetary transformation, impact events, oceanic shifts, and tectonic upheavals. Further scientific investigation remains essential. Drilling, mineral analysis, and geochronological studies to peel back Earth's layers and decode secrets embedded within. Confirming ancient deposits predating human activity could revolutionize our understanding of the pyramid's age and purpose. The monuments might not solely be products of a nascent civilization, but built upon, or borrowing from, Earth's ancient and mysterious foundations. In the end, the geological narrative of Giza adds a compelling chapter to our ongoing quest for knowledge. It urges us to look beyond the surface, beyond hieroglyphs and inscribed stones, and listen to Earth's rocks and formations. They may be telling us that Earth's history, a story intertwined with human development, is far more complex and ancient than we have yet imagined. The precise alignments of the Giza pyramids with celestial bodies suggest more than coincidence. They imply a complex understanding of astronomy by their builders. Their orientation towards specific stars and solstices indicates advanced astronomical knowledge that challenges conventional dating. Traditionally, these pyramids are attributed to Egypt's 4th dynasty, around 4,500 years ago. Yet, their deliberate alignments with constellations like Orion's belt and celestial events raise questions about whether such knowledge existed at that time, or if they were built in a different epoch altogether. Imagine the builders meticulously aligning the pyramids with specific stars. Such precision requires exact measurement and an understanding of celestial movements, including precession, the slow wobble of Earth's axis that shifts star positions over thousands of years. The structure's alignment with star positions centuries before or after their supposed construction hints at a deeper history. It suggests the builders had access to astronomy knowledge far surpassing primitive tools, or that this knowledge was inherited from an earlier civilization, possibly predating mainstream timelines of ancient Egypt. The geographical arrangements of the pyramids support this idea. Their positions, sizes, and angles follow geometric principles, indicating more than religious symbolism. Ratios within the pyramids, like the 1.618 Fibonacci ratio, point to advanced mathematical understanding. Such knowledge, often associated with Greek scholars, implies a timeline extending well beyond Egypt's recorded history. These precise ratios and alignments hint at a connection to an earlier, possibly lost civilization with sophisticated sciences. Some speculate these structures may be remnants of a global or extraterrestrial influence spanning thousands of years. Their alignments and formations seem to encode shared knowledge or purpose, possibly linked to a lost civilization or signals aimed at distant civilizations or celestial beings. These structures may have served as markers or messages, an ancient universal communication about cosmic cycles or knowledge. Further, some interpret the alignments as messages embedded in stone, containing information about Earth's history or instructions for future generations. If built before the Younger Dryas, a sudden climate change event around 12,000 years ago, it would imply a society with a level of sophistication that contradicts mainstream views of primitive early humans. This raises questions about lost knowledge and civilizations that vanished or became myths over time. Examining these alignments prompts reconsideration of current dating models. The builders might have employed a more advanced calendar system, such as those based on precession, understood centuries later. If so, the pyramids could be aligning with a cosmic clock predating accepted timelines, challenging our standard chronologies. Such implications challenge traditional timelines. Discovering that advanced astronomical knowledge existed far earlier would suggest humanity's history is longer, more interconnected, and more technologically advanced than previously believed. Instead of a linear evolution from primitive to sophisticated, earlier flashes of civilization, possibly lost or hidden, may have possessed mastery over astrology, mathematics, and engineering, the remnants of which are encoded in these structures. The idea that these structures were designed with awareness of Earth precession implies knowledge passing across ages. Did ancient builders possess secret sciences, preserved through generations or remnants of a lost global culture? Or did they receive knowledge from extraterrestrial visitors or cosmic forces enabling their precise alignments? The consistency of these formations with celestial phenomena indicates a shared conceptual framework, potentially religious, scientific, or mystical, that emphasizes understanding of the cosmos. This suggests widespread knowledge, not limited to a few experts, but part of a broader cultural worldview rooted in astronomy and geometry. Considering the pyramids are possibly older than traditionally thought prompts a re-evaluation of human history. They may have been built by a highly advanced, globally connected civilization predating Egypt's recorded dynasties. Such a civilization could have been wiped out by natural disasters, upheavals, or deliberate suppression, leaving their legacy in these monuments. In this context, these monuments are more than tombs. They are cosmic fingerprints, encoding a dimension of history that challenges current narratives. They may be a long-lost map or message, waiting to be decoded by future generations. Their orientations and complex geometry suggest their creators possessed an advanced understanding of the universe, mathematics, and time, knowledge possibly predating the Younger Dryas. Deciphering these celestial signatures might uncover a hidden chapter of human history, one where knowledge was universal and perhaps divine in origin. The implications are profound. If the pyramids reflect a deliberate connection to cosmic cycles and predate accepted timelines, they fundamentally alter our perception of human development. They suggest the story of human civilization is longer, more interconnected, and more technologically sophisticated than mainstream narratives acknowledge. These mysteries invite us to revisit ancient texts and traditions and consider that history as we know it may be just a thin veneer over a vast, complex past. A history the pyramids may have been built to preserve and communicate across ages. The pyramids' alignments with celestial bodies indicate a remarkable understanding of astronomy and mathematics. If such knowledge predated Egypt's dynasties, the inception of civilization extends much further into prehistory. Their construction may reflect knowledge of cosmic cycles, like precession, that was lost or forgotten over millennia but encoded in stone. This suggests an ancient, widespread tradition, possibly global, that possessed advanced sciences. Whether these structures were built by a civilization that predates written history, or by beings from elsewhere, their purpose and design reflect an aspiration to link Earth with the cosmos, to keep alive a cosmic clock controlling cycles of time, seasons, and celestial events. The idea that the pyramids are aligned with celestial cycles hints at an early understanding of astronomy's profound importance. Such alignment suggests that ancient cultures saw themselves as part of a larger cosmic order, requiring observation and mathematical precision. This indicates a shared worldview that integrated religion, science, and cosmic harmony. If their construction predates mainstream dating, these structures could be remnants of a global civilization's knowledge. Their alignments and geometric design imply a shared cultural or scientific tradition spanning continents and epochs, perhaps a continuous legacy beyond current understanding. Contemplating these alignments, they serve as more than monuments. They could be cosmic messages, encoded with knowledge of Earth's history, celestial cycles, or future predictions. They may be parts of an ancient, durable communication system designed to survive natural and human upheavals, accessible only through specific knowledge. The structures might have been created before the last ice age, during an era of global civilization far more advanced than we realize. Their purpose could have been to mark important cosmic events, serve as calendars, or act as signals in a celestial network aimed at maintaining harmony across the universe. This challenges the linear progression of human development. Instead, it suggests earlier civilizations, lost to time, possessed mastery in astronomy, mathematics, and engineering, rivaling or surpassing later communities. Their remnants are visible in the alignments and geometries of the pyramids, prompting a rethinking of our origins. The idea that ancient builders understood Earth's precession and designed their structures to align with specific celestial events centuries before they occurred raises questions about how knowledge was transmitted. Were these builders custodians of secret sciences, passed down through generations, or recipients of extraterrestrial signals? The consistency of these alignments across different structures indicates a shared, perhaps universal framework, rooted in religious or scientific principles that underscores their significance. Their design hints at a worldview where the cosmos is interconnected and meaningful, requiring mathematical and astronomical expertise. Reconsidering the age of these pyramids opens the door to unrecognized chapters of history, eras of advanced civilizations wiped from mainstream consciousness. Such cultures perhaps had vast knowledge, with their legacy surviving only in monumental structures and alignments. In essence, these monuments are cosmic fingerprints, clues to a forgotten past when human knowledge was vast, universal, and possibly divine. They challenge us to decode their messages, long-lost knowledge about Earth's history, celestial cycles, or cosmic laws. They beckon us to look beyond the surface and consider that they encode a long-lost understanding of the universe, a knowledge that might still be accessible. Their precise orientations and geometries reflect an understanding of the cosmos, mathematics, and time that could have been developed long before accepted, extending the timeline of human achievement. Deciphering these celestial signatures may reveal a hidden chapter of history, a story that rewrites our understanding of human origins and evolution. The implications are staggering. If the pyramids were purposefully aligned with cosmic cycles and predate known history, then human development is far more ancient and interconnected than we have realized. The story of human progress might be a tapestry woven from lost civilizations, extraterrestrial influences, and ancient wisdom waiting to be rediscovered. Considering the possibility that these structures were designed with knowledge of Earth's precession and celestial cycles, we revisit questions about transmission of sacred or scientific knowledge across ages. Were these builders custodians or transmitters of cosmic wisdom? Or did they receive signals from extraterrestrial sources, integrating celestial intelligence into their architecture? Their alignments suggest a shared, possibly universal conceptual system, religious, scientific, or mystical, that governed their worldview. This system indicates a sophisticated understanding of the universe's workings, an understanding that may have been widespread and fundamental, not limited to a few. Contemplating these ideas pushes us to reevaluate timelines. If the pyramid's alignments reflect an older, more advanced understanding, then human origins go deep into prehistory. They hint at a continuous, possibly interconnected development, perhaps interrupted by catastrophe or lost in myth. Ultimately, these monuments are more than tombs. They could be cosmic messages encoded in stone, preserved across millennia. They stand as silent witnesses to ancient knowledge systems, possibly originating from a lost global culture or cosmic visitors, designed to communicate across ages. Deciphering them might reveal insights into Earth's history, celestial cycles, or universal principles lost to time. Their alignments could be a form of celestial navigation, an ancient, durable code engineered to survive natural and human upheavals, waiting for modern interpretation. If these structures indeed predate the known history of Egypt, they imply human civilization's roots extend much deeper, with an advanced, interconnected, and possibly extraterrestrial influence. They challenge us to look beyond accepted narratives of progress and discover a more complex, perhaps divine story woven into these remarkable monuments. For centuries, scholars have viewed the Giza pyramids as the pinnacle of ancient Egyptian craftsmanship, monuments that symbolize an advanced, organized society flourishing around 3000 BCE. But what if these structures, long considered the climax of Egyptian civilization, are actually remnants of an even older era? Evidence hinting at civilizations predating known Egyptian history appears across multiple disciplines: archaeology, geology, astronomy, and mythology. Collectively, these indicators urge us to reconsider human development and explore the possibility that our ancestors achieved astonishing feats long before classical Egypt. One early clue is in the geological record. Certain sediment layers and mineral deposits suggest large-scale construction activity tens of thousands of years ago, well before Egypt's rise. Formations in the Nile Delta contain unusual deposits: helical silt, calcium carbonate formations, and mineral weathering patterns, which are hard to explain solely by natural processes. These features merge into older strata, implying human or intelligent activity long before the traditionally accepted timeline for Egyptian civilization. Underground and underwater structures also hint at a forgotten history. Sonar imaging and remote sensing have revealed submerged ruins and megalithic foundations that predate the pyramids. Some structures align with celestial events and display sophisticated planning and engineering that extend beyond what's expected from early societies. For instance, submerged temples near Alexandria and formations beneath the Nile Delta exhibit archaeological features: precisely cut stones, intricate alignments, symmetrical layouts that seem to surpass typical ancient craftsmanship. These findings suggest the existence of lost civilizations with advanced knowledge, possibly predating known Egyptian history by millennia. Ancient texts and mythologies further support this idea. Egyptian stories of a time when gods and beings with extraordinary knowledge inhabited the land evoke themes of cosmic cycles and creation. Similar motifs appear across civilizations worldwide: Mesoamerican, Mesopotamian, Indus Valley, suggesting a shared memory of a global civilization predating recorded history. Some researchers interpret these myths as allegories passed down through generations, describing an older civilization wielding advanced understanding of the cosmos, architecture, and technology. Archaeological anomalies challenge mainstream timelines too. Mysterious tool marks on stones and monoliths suggest techniques and precision traditionally thought impossible for early societies. Some stones feature ultra-precise carvings or drilling, indicating that an unknown or advanced knowledge might have existed. These artifacts may be remnants of a lost civilization, or of a much older culture whose skills were inherited or lost over time. Additional artifacts depict symbols and devices pointing to advanced technology. Some carved stones contain complex geometric patterns that seem to encode astronomical data or engineering principles. These carvings appear to align with celestial phenomena, implying an understanding of the universe beyond primitive societies. Some believe these symbols represent ancient knowledge of cosmic cycles, concepts incorporated into rituals and architecture, whose origins may reach far beyond conventional timelines. Celestial alignments in ancient structures offer another compelling piece of evidence. The pyramids, for example, align precisely to cardinal points, and stars like Orion's belt, Sirius, and the Pleiades. Researchers suggest that these alignments may be based on knowledge of much older celestial cycles, not just observable during Egypt's classical age. Possibly, ancient civilizations inherited astronomical knowledge from much earlier cultures, hinting at a long, interconnected human history. Most intriguing are microscopic and geochemical anomalies linked to Egyptian monuments. Isotope analyses of some stones reveal minerals inconsistent with local geology, but matching distant sources, implying complex trade or transportation methods. Transporting materials across vast distances would require advanced logistics and engineering skills. Such feats suggest that early builders had access to technology and organizational frameworks capable of supporting grand projects, long before mainstream estimates of civilization. Mythologies and sacred texts from various cultures also speak of a golden age, a time when humanity was in contact with divine beings, held cosmic knowledge, and built magnificent structures. The story of Atlantis, often dismissed as myth, may contain a kernel of truth. Plato's account describes a highly advanced civilization predating Egypt, with technology and wisdom surpassing what's known today. Some interpret these stories as memories of real civilizations that existed thousands of years earlier, civilizations whose achievements have since been lost or suppressed. Looking at ancient sites worldwide, such as Göbekli Tepe in Turkey, Malta's megaliths, and the Nazca lines in Peru, a recurring theme emerges: interconnected cultures that built monumental structures long before recorded history. These sites display similar craftsmanship, purpose, and astronomical alignments, suggesting a shared or inherited knowledge. This pattern indicates that much of the technological innovation behind these monuments might have originated in a civilization older than currently acknowledged. Thus, a picture emerges of humanity that is far older and more interconnected. The collective evidence, geological anomalies, submerged structures, mythic memories, complex artifacts, and precise celestial alignments suggest the existence of a highly capable civilization tens of thousands of years ago. This civilization may have possessed advanced engineering, astronomical understanding, and cultural wisdom, which were lost to catastrophe, deliberate suppression, or fading into myth. Future technological advancements promise more discoveries that could reshape our understanding of history. The story of human origins might be rewritten to include these ancient forgotten peoples, adding depth to our comprehension of what humanity can achieve. The echoes of these civilizations resonate in the stones of the pyramids, star alignments, and enduring myths across cultures. Their true influence remains buried in geological and archaeological records, waiting to be uncovered, a prompt to question our origins and the nature of human civilization's history. The idea that ancient civilizations influenced or even initiated the construction of the Giza pyramids before the Younger Dryas challenges our conventional understanding of human history. To imagine how these civilizations might have wielded such influence, let's explore epochs where knowledge, craftsmanship, and divine purpose intertwined in ways that seem extraordinary today. Many scholars view ancient Egyptian civilization as isolated, evolving gradually from earlier cultures. But what if this view is too narrow? What if those who built the pyramids inherited a global heritage, an ancient network of civilizations sharing advanced knowledge across continents, oceans, and millennia? This idea, gaining traction among alternative researchers, suggests that Giza's builders may have been influenced by, or descended from, a far older civilization that predates the last ice age. Imagine a civilization capable of transmitting knowledge long before recorded history, mastering techniques of stone machining, astronomical alignments, and mathematical precision that seem divine today. How could they have achieved such feats? How might their influence have shaped the builders of Giza? One possibility is that these ancient civilizations possessed advanced technological knowledge, perhaps acoustic levitation, crystalline energies, or resonance technologies that allowed them to manipulate stone with astonishing accuracy. Artifacts like intricately carved megaliths and precise geometric layouts across the world suggest the craftsmen inherited techniques rooted in a deeper knowledge base. These skills may have been passed through secret traditions, encoded teachings, or preserved in sacred texts, symbolism, and architecture. Another angle involves their astronomical and cosmological understanding. Many ancient cultures built monuments aligned with celestial events, solar solstices, lunar cycles, star risings, implying detailed cosmic knowledge. The Giza pyramids' remarkable cardinal alignments challenge our understanding of ancient surveying. Could this knowledge have originated from even older civilizations whose grasp of celestial mechanics was more advanced? If so, their influence might have been transmitted via trade routes, migration, or shared sacred texts and symbols embedded within architecture. The concept of a global ancient civilization also raises the possibility of cultural exchange extending beyond isolated regions. The similarity between Egyptian pyramids, Mesopotamian ziggurats, and Mesoamerican pyramids hints at a universal architectural impulse, possibly rooted in a shared heritage or an ancient knowledge network. How might this influence have manifested practically? It's plausible that ancient engineers and architects carried a collective subconscious memory of sacred principles, an understanding of manipulating the environment to achieve monumental constructions with astronomical and mathematical precision. Such knowledge could have been encoded in mythologies, rituals, and sacred sites, transmitted through generations and civilizations. Civilizations might also have used celestial alignments as temporal charts and navigational tools. The pyramid's orientation and the stars' positions, especially the Orion constellation, could be remnants of an ancient cosmic sacred knowledge, designed as calendars or cosmic keys, linking human consciousness with celestial cycles. In this light, the builders weren't just craftsmen, but custodians of a spiritual and scientific tradition, spanning continents and epochs. They may have possessed stellar cartography, calibrating constructions with cosmic accuracy, transmitted through oral traditions rich in symbolism. Such teachings might encode complex mathematical and astronomical data, decipherable only by initiates. Symbols, numerals, and architectural ratios in Egyptian structures resemble patterns found worldwide, suggesting a shared knowledge repository or influence. The influence wasn't solely technical or scientific. Religious ideas and mythologies could have travelled across ancient cultures, shaping the purpose and meaning of the pyramids. Concepts of the afterlife, resurrection, or divine kingship might have roots in an almost universal worldview. The pyramid shape itself, seen globally, could symbolize the sacred mountain, an axis mundi connecting heaven and earth, shared through a lost web of cultural exchange. If these civilizations had such influence, it suggests the builders of Giza drew from an ancient shared treasury of knowledge. They might have refined it, integrating astronomical alignments, mathematical principles, and sacred geometries into a monument that transcended mere tombs, a cosmic instrument tuned to celestial cycles, perhaps awakening consciousness or serving as a gateway for spiritual ascent. Even more provocative is the idea that this influence came from a proto-civilization, possibly predating the last ice age, that used technology and spiritual knowledge to advance consciousness. This civilization might have accessed higher dimensions, communicated through energy fields, or harnessed crystalline energies within Earth's bedrock. Their influence could have been transmitted through ancestral memories, ley lines, or energetic conduits, reaching Egypt long before recorded history. The role of extraterrestrial influences should not be dismissed. Some theories propose that ancient civilizations received guidance or assistance from beings who possessed advanced knowledge, perceived as gods or star visitors. The precision, celestial alignments, and harmonic structures of the pyramids can be seen as communication, an invitation to align with the cosmic order. Accepting that ancient influences shaped the pyramids broadens our understanding of human history. Perhaps we are the heirs of a long-standing tradition, one that predates recorded civilizations. The builders might have inherited a cosmic blueprint of existence, encoded in stone, linking us to primordial knowledge. The pyramids stand as living monuments, embodiments of a sacred cosmology connecting human consciousness to the universe. They reveal an understanding of cosmic rhythms, energies, and sacred geometries handed down from ancient civilizations, whose influence remains hidden, waiting to be rediscovered. This perspective urges us to rethink the timeline of human achievement. The influence of civilizations before the Younger Dryas might have sparked an evolutionary leap, one rooted in spiritual awakening and scientific insight, culminating in these extraordinary monuments. The Giza pyramids, thus, are not just archaeological marvels but spiritual keys, passages for ancient wisdom to whisper across ages, inviting us to uncover our true heritage within their stones. 926 words. The mysteries surrounding the origins of pyramid-building knowledge are as profound as the pyramids themselves. For centuries, scholars, archaeologists, and enthusiasts have been captivated by how ancient civilizations, often credited with primitive technologies, constructed structures that continue to baffle modern engineers. When exploring beyond accepted timelines, the questions become even more compelling, challenging our understanding of human history and technological development. One perplexing aspect is the precision and sophistication evident in pyramid construction. The Great Pyramid of Giza embodies advanced geometry, astronomy, and engineering. Its exact alignment with cardinal points, measurements matching cosmic constants, and hidden mathematical codes suggest knowledge that many believe should not have been available at that time. The tools, techniques, or conceptual frameworks used remain elusive. Were these builders in possession of lost technologies, or did they inherit knowledge from civilizations predating Egypt's Old Kingdom by thousands of years? Adding to this enigma are ancient sites worldwide, often overlooked. From Malta's megalithic temples to underground tunnels in South America, the global distribution hints at a shared tradition of monument construction. Similarities in layout, purpose, and symbolism suggest a common origin or an ancient knowledge network far older than current archaeological consensus admits. The materials and methods used to carve and transport massive stones deepen the mystery. Radiocarbon dating and geological analysis imply capabilities beyond what is believed possible for the period. How did ancient builders quarry, shape, and move massive stones without the wheel or modern machinery? Some theorists propose they used lost ancient techniques, possibly employing advanced metallurgical knowledge or controversial ideas like external assistance from unknown sources. Cultural transmission offers another layer of intrigue. Knowledge of complex engineering and astronomical alignments was spread across diverse civilizations: Incas, Mayans, Egyptians, Southeast Asians. This could imply an ancient global civilization or interconnected cultures sharing knowledge that has since vanished. The mechanisms, through oral tradition, cultural exchange, or unknown ancient communication, remain mysterious. The origins of mathematical understanding also evoke curiosity. Pyramid ratios, such as the Golden Ratio, suggest an advanced mathematical tradition. But where did this knowledge originate? Did it emerge from a different perception of reality, perhaps rooted in spiritual or symbolic frameworks? Or was it inherited from civilizations with advanced knowledge lost during periods of chaos or decline? The purpose behind these constructions remains a profound mystery. While many see pyramids as tombs or religious monuments, some researchers propose more profound functions. Could they have served as astronomical observatories, energy conductors, or portals, harnessing cosmic energies or facilitating communication with higher dimensions? If so, did their builders possess cosmic or spiritual knowledge so advanced that it's almost beyond understanding? And why was this knowledge so meticulously encoded? The possibility of civilizations predating recognized states complicates the mystery. Evidence from submerged structures, anomalous artifacts, and unexplained relics hint at civilizations with advanced knowledge that vanished in cataclysmic events, possibly related to the Younger Dryas period, around 12,000 to 11,500 years ago. If such civilizations achieved high technological and spiritual levels, their knowledge could have been recycled, hidden, or lost through natural disasters or upheaval. Plate tectonics, magnetic anomalies, and underwater ruins suggest the landmass where pyramids sit might have been different in the distant past. Could the original builders have understood Earth's geological and electromagnetic properties? Might they have used this knowledge to align structures with planetary and celestial cycles? If so, their understanding of natural forces and cosmic patterns may have been far more advanced, rooted in a suppressed or forgotten scientific tradition. The archaeological record raises questions about authenticity and preservation. The stones used are remarkably uniform, yet modern historians struggle to explain the advanced methods involved in their quarrying and fitting. Some structures seem reworked or restored, with earlier phases predating accepted dates. This suggests that pyramid construction knowledge might have existed in a much earlier epoch, evolving and transmitting over time before being lost or obscured. Beyond technical mysteries, spiritual and symbolic aspects continue to confound researchers. Hieroglyphs, carvings, and inscriptions, though often incomplete, hint at complex cosmological understandings. Many believe that the symbolic language encoded in these structures holds keys to secret knowledge about the universe, consciousness, and existence itself, locked within codes, numerology, and sacred geometry. Unlocking these could revolutionize human understanding, but evidence remains fragmentary, encrypted, or biased by historical preconceptions. The question of whether we are the first to attempt to uncover these secrets also adds to the mystery. Some propose cycles of rise and fall based on cosmic or planetary rhythms over tens of thousands of years. This suggests ancestors possessed knowledge and technology now lost through chaos, conquest, or natural disasters. If true, our ancestors might have had a deeper understanding of the universe, only partially preserved or rediscovered in later epochs. Exploring these mysteries reveals that the origins of pyramid knowledge may not have simple answers. Instead, it offers a portal into a vast, largely forgotten past, when consciousness, technology, and cosmic understanding were intertwined. Unraveling this enigma requires a multidisciplinary approach, combining archaeology, geology, astronomy, psychic research, and speculative physics. With new discoveries and perspectives, the true origins may someday emerge, rewriting our view of human achievement and cosmic connection. The more we investigate, the more apparent it becomes that ancient pyramid knowledge likely stems from a profound and perhaps lost understanding of natural and cosmic laws. Its roots may be in spiritual traditions, advanced scientific understanding, or a combination of both, concealed or forgotten over millennia. Some believe fragments of this knowledge survive in esoteric traditions or hidden within sacred sites, awaiting rediscovery. Ancient texts, symbols, and alignments continue to hint at mysteries not yet fully understood. These hold potential keys to unlocking a deeper comprehension of our origins in the universe. Advancements in technology and cross-disciplinary research might finally shed light on this puzzle, revealing connections that could transform human history. Yet, the full story remains elusive. Whether the builders were guided by divine inspiration, lost technologies, extraterrestrial assistance, or an advanced indigenous knowledge system is still debated. The true origins of pyramid building knowledge may forever remain shrouded, but each discovery brings us closer to understanding an extraordinary chapter of human history. Ultimately, the mysteries of pyramid origins reflect a collective longing for understanding our roots. They challenge linear narratives of progress and open the possibility of a much more ancient, intertwined story, where knowledge, spirituality, and science converge. As new evidence emerges, the quest to uncover these secrets continues, an ongoing journey into humanity's mysterious past, waiting to be unveiled. The evidence suggesting the Giza pyramids may predate conventional timelines challenges what we think we know about human history. For centuries, the accepted narrative placed their construction around 4,500 years ago during Egypt's 4th dynasty. This dating relies on archaeological artifacts, historical records, and radiocarbon analysis of organic materials found at the sites. But what if this timeline isn't entirely accurate? What if these structures are much older, perhaps dating back to a pre-Younger Dryas era, when advanced civilizations might have existed long before known history? A key piece of evidence fueling this debate is geological analysis of materials around the pyramids. Certain studies point to construction materials that appear anomalously weathered or aged, suggesting they might be older than traditional dating indicates. Researchers have identified strange mineral deposits and erosion patterns on limestone blocks that defy the expected age bracket. Some features resemble natural weathering processes that can take tens of thousands of years, much longer than the roughly 4,500 years since the pyramid's purported construction. Furthermore, geologists highlight isotopic signatures and mineral formations difficult to reconcile with standard dating techniques. These include unusual crystallizations and silica deposits, which could only form under specific ancient climatic conditions predating the accepted age of the pyramids. Such evidence hints these stones may have been reused or repurposed from much older structures, prompting reconsideration of the construction sequence and broader Egyptian history. Archaeological evidence adds weight to this challenge. While traditional excavations have uncovered artifacts dating to the Old Kingdom, some researchers point to anomalies in nearby settlements and subterranean tunnels. These suggest earlier layers of occupation or construction not fitting within the established timeline. Notably, underground chambers and corridors beneath the Giza plateau show signs of prior use and modification, as if they belong to a civilization predating the 4th dynasty. Support also comes from astronomical alignments within the structures. The precise orientation of the pyramids isn't random. They point to important stars and constellations. For instance, the main pyramids are aligned with Orion's belt, a pattern that has intrigued scholars for centuries. Some argue these alignments were for astronomical observations, but others suggest they encode older celestial knowledge, possibly from a much earlier civilization. This possibility implies a cultural memory far predating the known Egyptian builders. If the pyramids were constructed with star maps or astronomical knowledge, it indicates a shared knowledge base extending into distant pasts. Such knowledge might have been passed through myths, sacred texts, or archaeological remnants, or even preserved secretly. The idea resonates with the notion that the pyramids could embody fragments of a lost, advanced knowledge system. Adding to this, cultures and artifacts worldwide suggest a globally interconnected history of advanced civilizations. Megalithic sites in South America, Europe, and Asia display similar construction techniques and architectural features despite vast differences. Some researchers view these similarities as more than coincidence, hinting at a shared ancient knowledge or a common origin from a prehistory when humanity was more technologically advanced than currently believed. Even more compelling are mythological records and sacred texts. Many describe a lost golden age, an era when humans possessed extraordinary wisdom and skills. Stories of Atlantis, Mu, and other legendary civilizations are prominent examples. Could the pyramids be remnants of this bygone era, embodying knowledge that predates current understanding? Such structures may have survived multiple cataclysms, including the Younger Dryas, a rapid climate cooling period around 12,700 years ago, adding weight to this hypothesis. The Younger Dryas itself might provide a crucial piece of the puzzle. Climate evidence indicates this abrupt shift had catastrophic impacts on early human societies. Yet, some paleoclimatic data suggest that before the Younger Dryas, Earth experienced warmer, more stable conditions, potentially allowing early civilizations to develop and flourish. If the pyramids or their precursors originated during this earlier, more hospitable period, their construction and purpose would extend far back in time, challenging the traditional 4,500-year timeline. Radiometric analyses such as thermoluminescence dating have been used to determine ages of these materials, sometimes indicating dates much older, possibly by thousands of years. But these results are often contested or inconclusive. Still, patterns of anomalous dating results across multiple studies suggest the chronological framework might need revision. When geochemical, archaeological, and astronomical evidence converge to support an older origin, the case for a rethought timeline becomes more compelling. Implications of a revised timeline ripple through our understanding of human evolution, societal development, and technological progress. If advanced civilizations with remarkable engineering skills existed far earlier than assumed, what else might we have missed? Could there be forgotten civilizations destroyed by climate change or catastrophic events, whose remnants still lie buried beneath layers of sediment or earth? The possibility that human history is much older than accepted opens a Pandora's box of questions. It questions the long-held linear narrative of progress, which suggests humanity's achievements are incremental, evolving through a single line of cultural and technological development. Instead, evidence for an older origin hints at lost knowledge, advanced technologies, and civilizational heights long erased by time and disaster. Our ancestors' capabilities could have been far greater than traditionally thought, creating a much more complex and rich human history buried deep beneath the surface. This collective evidence causes the very fabric of how we understand human history to shift. The possibility that the Giza pyramids and other ancient wonders are relics of a pre-Younger Dryas civilization urges us to re-evaluate when humanity first arose and what it was capable of. It pushes us to reconsider ancient texts, archaeological layers, and geological clues with fresh eyes, recognizing that our story might be far more ancient, complex, and interconnected than the conventional timeline suggests. In this re-evaluation, we are encouraged to look beyond just new dates. We are prompted to consider a broader perspective that acknowledges gaps in our knowledge and the potential existence of lost chapters in human history. The stones at Giza could contain secrets about our distant ancestors' knowledge, scientific, spiritual, or technological, that could redefine our understanding of human achievement across ages. Unlocking these secrets could help us better understand who we are, where we came from, and the full extent of human potential. This pursuit challenges us to think beyond accepted histories, recognizing that the story of humanity may extend far deeper and older than our current models suggest. As more evidence emerges, our view of our ancestors and their accomplishments and long-lost worlds may undergo profound change. This ongoing investigation continues to reshape our understanding of the past and our place within it, suggesting human history might be more ancient, complex, and mysterious than previously imagined. Ignoring 119 words, the implications are staggering and challenge everything we thought we knew about the capabilities of our ancient ancestors. If the Giza pyramids were constructed before the Younger Dryas, a period roughly 12,000 years ago marked by sudden climate changes, then it suggests our ancestors possessed a level of technological prowess and scientific understanding far beyond conventional archaeological narratives. For centuries, history has told a story of gradual human progress, starting with primitive tools and advancing over tens of thousands of years. Early humans, according to this traditional view, lacked the sophisticated engineering, mathematics, and organizational skills necessary for monumental structures like the pyramids until relatively recently. Yet, the possibility that these pyramids are much older implies that ancient civilizations may have had access to lost knowledge, technologies, or methods long before Egypt's known dynastic culture. One profound implication is that the engineering feats, precise stone cutting, transporting massive blocks, and astronomical alignments may have been achieved with understanding and tools we have yet to comprehend. The high precision in fitting these blocks suggests advanced geology and material science. Techniques such as sophisticated levitation, advanced metallurgy, or acoustic technologies might have been employed, methods we haven't yet imagined or recovered evidence for, facilitating the accurate sculpting and placement of enormous stones. Historically, such accomplishments were attributed to thousands of workers wielding simple copper tools and brute force. But this perspective struggles to explain the precision and alignment observed. If the structures predate Egypt's known civilization by thousands of years, it raises the possibility that ancient architects possessed knowledge of astronomy, mathematics, or physics, perhaps even utilizing nearly mythical technologies. The idea of an older origin hints at shared or transferred technological knowledge across ancient cultures. It raises questions about whether a lost civilization or series of civilizations laid the groundwork, passing down advanced knowledge that was later lost during climatic upheavals like the Younger Dryas, or even earlier. Their cumulative understanding might have been erased, leaving only faint clues. This suggests that human technological development was not necessarily linear. Instead, periods of high achievement could have been followed by collapses that erased knowledge. The notion that ancient builders had access to advanced science and engineering, only to lose it over millennia, paints a complex ancient history richer than the accepted narrative. Such a view could reshape our understanding of human progress and the depths of ancient ingenuity. It fuels speculation about external influences, whether extraterrestrial or non-human intelligences, playing a role in early technological development. The extraordinary precision implied could suggest our ancestors either possessed hidden knowledge or received guidance from otherworldly sources. While controversial, these ideas merit consideration given the scale and sophistication of these structures. They might reflect knowledge or technologies we've forgotten or discarded. Understanding that such structures could have been built with potentially lost ancient knowledge challenges our view of human evolution. It invites reconsideration of whether early humans were primitive or part of a broader experience that has been obscured. If civilizations with mastery over technology capable of constructing these monuments existed thousands or tens of thousands of years ago, then current views of technological progress are incomplete. This also impacts archaeology and archaeoastronomy. These disciplines might need to widen their scope to include possibilities of advanced ancient knowledge systems, which could be embedded in alignments, symbols, or structural features of monuments. Evidence of advanced mathematical understanding, astronomy, or proto-scientific principles might be hidden within these designs, waiting to be discovered or reinterpreted. The implications also extend to energy and materials science in antiquity. How did ancient builders move and manipulate colossal stones with such precision? Did they harness still undiscovered energy sources or mechanical principles? Could Merkabah principles akin to gravitational or acoustic levitation have been employed? Might they have used natural phenomena or methods that drastically increased building efficiency, methods surpassing current scientific understanding? The prospect that such capabilities existed deep in antiquity implies civilizations might have used technologies that profoundly altered their environment, perhaps even manipulating climate or geological processes before these skills were lost. This might explain enigmatic landscape features or remnants of ancient land management and deforestation, which left little trace in conventional records. It also prompts a re-evaluation of how knowledge was transmitted across generations. If lost civilizations possessed advanced technology, how was it preserved, and why was it erased or forgotten? Were there deliberate efforts to conceal this knowledge, perhaps by subsequent civilizations seeking control or restriction? Questions about lost libraries, underground vaults, or secret societies that carried fragments of ancient wisdom arise. On a broader scale, these revelations influence efforts to find evidence of extraterrestrial contact or ancient non-human influences. Extraordinary ancient structures, if driven by technologies beyond our current understanding, might imply external or alien assistance in humanity's remote past, or that we're descendants of a highly advanced ancient civilization now vanished. Acknowledging ancient advanced technologies might also inspire contemporary researchers. Re-examining artifacts, texts, and engineering methods with fresh perspectives could lead to innovations. A multidisciplinary approach, integrating archaeology, physics, engineering, and quantum science, could help uncover principles used by our ancestors. The idea that pyramids and other megalithic monuments predate mainstream dates hints at an enormous, largely unexplored chapter of human history, one filled with technological mastery, spiritual insights, and possibly contact with realms beyond our current knowledge. It prompts us to question whether human evolution is unique, or if recurring cycles of technological progress followed by catastrophic loss have shaped our past. It encourages deeper exploration of these silent stones and the stories they may hold. These implications are not purely academic, they strike at the heart of human identity. Recognizing that ancient civilizations might have achieved extraordinary technological heights could inspire us to look inward, to rediscover and unlock dormant aspects of collective consciousness and ingenuity. It reminds us that history may conceal untold chapters filled with wisdom and achievements, and that we are only beginning to glimpse the vast scope of humanity's potential. 919 words exactly. Throughout history, our understanding of the past has evolved, shaped by discoveries that challenge accepted narratives. What if some timelines we've believed are mistaken? New evidence, such as claims that the Giza pyramids predate the traditional 4th dynasty date of around 2500 BCE, could force us to reconsider entire chapters of history. This has profound implications for how we date civilizations, interpret archaeological finds, and understand human development. Traditionally, dating ancient monuments relies on methods like carbon dating, stratigraphy, linguistic analysis, and historical records. These tools have provided a consistent timeline, anchoring Egypt's Old Kingdom, the pyramids, and other cultures within a linear framework. However, these methods aren't infallible. Organic materials are scarce or contaminated, earth layers disturbed over millennia, leading to potential misinterpretations. Evidence suggesting the Giza pyramids might predate their conventional timeline, geological analyses indicating older stones or astronomical data hinting at earlier alignments, raises the possibility that entire frameworks need revision. Could a civilization with advanced knowledge have built these structures long before Egypt's 4th dynasty? Or are they remnants of an older, complex history obscured over time? Reassessing timelines isn't just about dates. It involves reconstructing human history to accommodate new evidence. If the pyramids are older, what does that say about their builders? Might a sophisticated, possibly lost society have created structures so precise they seem beyond a primitive civilization? If so, it challenges our broader view of human progress. The foundation of historical periods depends heavily on dating. Egypt's timeline includes pre-dynastic, early dynastic, Old Kingdom, Middle Kingdom, and New Kingdom, each with distinct cultures. If sites like Giza date to before the pre-dynastic era, then Egypt's entire development, and possibly global history, must be re-evaluated. Advanced civilizations could have risen and fallen long before recorded history, slipping into prehistory with scant traces. Such shifts would ripple across archaeology, geology, paleoclimatology, and archaeoastronomy. Scholars have linked cultural developments to specific periods based on artifact styles, radiocarbon dating, and texts. But if new evidence indicates an older origin for monuments, existing dating methods might require recalibration. Our assumptions about ancient human development, migration, and technological progress could need revision. This redating opens fascinating possibilities. Ancient global connections. Could pyramids and megalithic structures worldwide, like Göbekli Tepe in Turkey, Malta's megaliths, South American sites, and Asian monuments, be part of a larger interconnected civilization? If Giza's pyramids are older, perhaps these sites form a network sharing technological or cultural motifs. Such a notion challenges conventional archaeological views. Revising timelines based on new findings does more than shift dates. It questions assumptions about human development, intelligence, and societal complexity. It suggests ancient humanity was capable of remarkable feats long before classical civilizations emerged. This hints at cyclical rise and fall of civilizations, with traces surfacing only now through modern technology. But revising history also involves risks. Skeptics warn against hastily rewriting accepted narratives based on limited evidence. Dating methods like radiocarbon, geology, and astronomy have margins of error. The danger is distorting complex cultural histories to fit new data. However, scientific progress relies on challenging assumptions and refining models to reflect the best evidence, even if it means rewriting long-established chapters. Such revisions could foster interdisciplinary research, prompting scientists, archaeologists, and historians to develop new dating techniques. Cutting-edge technologies, like microerosion analysis, neutron diffraction, and advanced astronomical modelling, could confirm or disprove these hypotheses. Each discovery would be scrutinized, leading to a more nuanced understanding of our past. Ultimately, reorganizing historical periods based on emerging evidence underscores the dynamic nature of human knowledge. History isn't static, it's a narrative continually refined by discoveries. If the evidence withstands scientific rigor, we may rewrite the story of our ancestors, acknowledging humanity's potential to be much older, more complex and interconnected than previously thought. This prospect invites us to keep questioning, exploring, and remaining open to the idea that recorded history is just a chapter in a larger story. If pyramids predate their mainstream dating, it reminds us that the true story of humankind may be buried beneath sediment, myth, and time, waiting to be uncovered. The past is rarely straightforward, and each new find reshapes our understanding of origins, achievements, and the mysteries of bygone eras. The acknowledgement that some timelines may shift encourages continuous inquiry and skepticism, essential for understanding our roots. Each archaeological breakthrough, whether confirming or challenging current models, brings us closer to the truth. This ongoing process ensures that our histories are flexible, capable of change when credible new evidence emerges. Some suggest that a revised timeline accommodating older structures could alter our perception of technological development. The existence of ancient, sophisticated monuments implies early humans possessed advanced engineering skills, or that a lost civilization with superior knowledge once thrived. These ideas challenge the notion of slow linear progress, pointing instead to rapid, perhaps cyclical bursts of ingenuity. Such speculations raise questions about cultural diffusion. Did knowledge spread across continents via trade, migration, or independent innovation? Or was there an earlier interconnected civilization that shared technological and cultural principles? An older interconnected world reconstructs a narrative of shared human achievement on a global scale. Reconsidering established timelines and periods could also reshape our view of human potential. It suggests our ancestors might have been capable of remarkable, forgotten accomplishments, overlooked due to bias and limited evidence. Recognizing this potential shifts our understanding of human capabilities and challenges stereotypes of primitive early humans. In this context, technological innovation in archaeology becomes key. Improved methods increase our ability to uncover deeper histories. New techniques could confirm or disprove the antiquity of structures like Giza, leading to more accurate reconstructions of human history. The stakes are high. While revisions promise richer, more complex histories, they require rigorous testing and cautious interpretation. Premature conclusions can distort cultural histories and undermine science credibility. But standing by evidence and questioning assumptions is essential for progress. This process exemplifies the scientific method, challenging current knowledge, testing hypotheses, updating models. It keeps understanding fluid, adaptable to new evidence. As tools and methods improve, so does our capacity to uncover the true scope of human history. In conclusion, the potential reorganization of history based on emerging evidence highlights the evolving nature of knowledge. Human history is shaped by ongoing discovery and inquiry. If new data shows structures like Giza are older than believed, it would profoundly reshape our view of human origins, societal complexity, and global interconnectedness. It's an exciting prospect, reminding us to question old narratives and explore new possibilities. The full story of humanity might be hidden beneath layers of sediment, myth, and time. Every discovery brings us closer to understanding a potentially more remarkable, interconnected, and ancient past than we have imagined. The story of humankind continues to unfold, inviting us to look deeper, think bigger, and embrace the mysteries that remain. If the Giza pyramids and other Egyptian monuments predate the accepted timeline, potentially existing before the Younger Dryas period, it could radically alter perceptions of ancient Egyptian culture and its origins. The implications ripple through our understanding of human history, civilization development, and the transmission of knowledge across millennia. Traditionally, Egyptologists date the construction of the pyramids to around 4,000 to 5,000 years ago during the 4th dynasty. This fits with the emergence of a centralized state, religious beliefs, and advancements in astronomy and engineering. It portrays a civilization that achieved remarkable feats relatively late in human development, building on generations of accumulated knowledge. The conventional view suggests a linear evolution, primitive societies gradually becoming complex technological civilizations. However, evidence indicating the pyramids are much older, perhaps predating the Younger Dryas, about 11,000 years ago, challenges this narrative. It implies a civilization or body of knowledge far older than previously believed, potentially predating the end of the last ice age. This raises critical questions. What would this mean for our understanding of ancient Egyptian culture? First, it suggests that ancient Egyptians inherited a highly developed, sophisticated tradition from ancestors we have yet to discover or understand fully. Their architecture, astronomy, and possibly spiritual systems might have roots traceable to this earlier epoch. Instead of viewing Egyptian culture as slowly evolving, it hints at the existence of advanced civilizations or technological knowledge circulating in the distant past, perhaps lost or deliberately suppressed over time. This shifts the story from one of isolated human innovation to a narrative of interconnected, enduring knowledge. Imagine civilizations capable of designing and constructing massive stone structures with astronomical precision thousands of years before traditional dates. The ancients could have inherited a legacy, an engineering blueprint or preserved knowledge, passed down through generations or hidden in secret traditions. It prompts us to reconsider how much of ancient history is based on surviving remnants of a much older, more advanced culture. Furthermore, an earlier origin challenges the idea that civilization developed gradually. Instead, significant leaps might have happened in prehistoric times, driven by unknown forces or accidental discoveries. Humanity may have possessed knowledge or technologies, tools, energy sources, astronomical understanding, that enabled the construction of these structures long before the known rise of complex civilization. This raises profound questions about the dissemination and loss of knowledge. If ancient Egyptians inherited this wisdom from a prior civilization, what happened to it? Was it preserved, hidden, or deliberately destroyed? Many researchers point to lost civilizations, Atlantis, Lemuria, or others, that might have once possessed advanced knowledge. If these monuments predate accepted dates, we may need to consider these civilizations' roles in shaping human progress, only to be forgotten or suppressed over millennia. Understanding this could also reshape how we interpret Egyptian religion, myth, and symbolism. The spiritual systems, rituals, and iconography associated with pyramids and sacred sites might be remnants or echoes of an ancient worldview rooted in cosmic understanding that predates classical Egyptian civilization. Symbols like notched collars, obelisks, and celestial alignments could be more than artifacts. They might connect to lost astronomical knowledge inherited from a much earlier epoch. It impacts our view of human potential as well. The engineering feats of the Egyptians are often seen as the pinnacle of ancient skill, achieved after centuries of gradual progress. But if these feats stem from knowledge inherited from an earlier civilization, it suggests human ingenuity has existed far longer than we thought. We might have underestimated our ancestors, assuming their achievements were isolated or accidental, when in fact they were part of a continuing tradition of advanced knowledge. On a broader scale, this challenges the archaeological record, which relies heavily on stratification and radiocarbon dating. If structures like the pyramids are older than current estimates, much of what we understand about prehistoric times needs re-evaluation. It encourages scientists and archaeologists to revisit artifacts, geological layers, and cosmic alignments with fresh perspectives, potentially uncovering evidence of civilizations lasting far longer. This perspective also invites investigation into unexplained phenomena associated with ancient Egypt. Anomalies such as the pyramids' precise astronomical alignments, underground chambers, and mastery of acoustics and energy could be relics of advanced technologies developed by ancient creators whose origins remain elusive. The possibility of an earlier origin suggests that ancient Egyptian culture was part of a vast network of knowledge transfer across regions and cultures on prehistoric Earth. They could have been custodians or inheritors of this ancient wisdom, preserved through their monumental architecture and religious systems. Such connections might explain similarities between Egyptian, Mesopotamian, Mesoamerican, and other ancient cultures, echoes of a shared ancient wisdom predating recorded history. Altogether, embracing an earlier origin for the Giza pyramids challenges not just our history books, but our entire understanding of human development. It urges us to think beyond linear narratives and consider a complex, interconnected story. one in which ancient civilizations possess knowledge and technologies still beyond our reach. It rekindles the quest to uncover the truths buried beneath layers of time, prompting us to reimagine the dawn of human civilization and our cosmic journey through ages. What if the greatest secrets from the past still remain hidden, waiting to reshape our understanding of who we are and where we come from? The pursuit of these mysteries could redefine beliefs about our ancestors' capabilities and perhaps unlock new potentials for our own civilization. If the pyramids and other structures predate current estimates, the implications extend far beyond archaeology. They challenge assumptions about progress, technology, and human ingenuity, suggesting our ancestors may have been far more advanced than modern history recognizes. It forces us to reassess the origins of civilization, the nature of lost knowledge, and the possibility that ancient wisdom has been preserved in secret and hidden, deep within our collective memory. Realizing that the roots of ancient Egyptian culture and technology may be deeper and older than traditionally believed could revolutionize how we view history. The idea of a more ancient, sophisticated past encourages us to question established narratives, explore unexplained phenomena, and seek connections across civilizations rooted in a shared, distant past. It invites a new exploration, one that promises to redefine humanity's story of progress and potential. Ultimately, the concept of an earlier origin suggests many of human history's greatest secrets are yet to be uncovered. These discoveries might not only reshape our understanding but also inspire future generations. If we could unlock the knowledge buried beneath the sands of Egypt and layers of time, we could gain insights into technologies and philosophies that could propel our civilization forward. The possibility that the greatest secrets of the past still lie hidden beckons us to look deeper, think broader, and dream bigger about human achievement across cosmic ages. The implications of these ancient mysteries ripple through our understanding of technological diffusion and independent development. If the Giza pyramids, and perhaps other monumental structures of similar scale and sophistication, predate accepted timelines, especially if they reach back before the Younger Dryas, then our narratives about human progress might need rethinking. The conventional story depicts gradual human innovation, small steps building on previous knowledge, passed down through generations, with societies refining tools, techniques, and engineering over centuries or millennia. It's a linear progression, civilizations standing on the shoulders of predecessors, slowly advancing toward higher cultures. But what if similar monumental feats appeared independently across different parts of the world, seemingly disconnected in time yet aligned in purpose and design? Such a pattern challenges the purely diffusion-based model. This prompts questions. Did ancient builders share knowledge across vast distances, possibly via early seafaring contacts or lost global networks? Or did these structures emerge independently? Perhaps civilizations, separated geographically, arrived at similar solutions due to the universal human drive to understand, harness, and shape the world around them. Traditionally, technological diffusion is believed to occur from centers of advanced civilizations outward through migration, trade, or conquest. But if pyramids and other megalithic sites are demonstrably older than accepted, this suggests either their builders possessed access to technologies beyond diffusion explanations, or these civilizations independently discovered similar innovations to solve complex engineering challenges. Imagine societies across continents independently discovering principles of mathematical alignment, geology, and astronomy required for such precise constructions. Their solutions could have converged due to facing similar problems, rather than borrowing from one another, an example of convergent technological evolution. Just as cultures worldwide independently invented the wheel or mastered fire-making driven by common needs and constraints, these ancient structures might reflect similar universal pursuits. The idea of independent development becomes even more profound if advanced knowledge, perhaps lost over time, existed within these civilizations. Producing such precision at scale without modern tools suggests high intellectual capacities. Could they have possessed technologies that vanished, traces perhaps hidden in artifacts, geology, or celestial alignments, forcing us to piece together clues rather than find direct technological remains? Alignments of pyramids and megalithic sites with celestial bodies suggest a remarkable understanding of astronomy. Egyptian pyramids, for example, align with specific stars and celestial events, Some researchers propose their orientation indicates processional knowledge extending thousands of years before accepted dates. If such knowledge predates the Younger Dryas by tens of thousands of years, the origins of astronomical science could be much older than believed. This opens the possibility that ancient peoples either transmitted these insights through lost global networks, akin to an old world knowledge bank, or arrived at similar realizations independently through observation and experimentation. Both scenarios hold profound implications. Either a shared ancient knowledge was preserved and passed on, or human curiosity led different cultures to similar discoveries. If civilizations independently developed advanced understanding, it suggests human curiosity and ingenuity are innate. We tend to equate sophistication with societal complexity and resources, but the ancient structures hint at deep intellectual mastery that transcended tools and social organization. Alternatively, widespread knowledge transfer may have occurred through explorers, traders, or oral traditions crossing continents. If core scientific principles and techniques were preserved and shared via symbolic codes or celestial alignments, it would bolster the diffusion model. Yet, the lack of conclusive evidence of a global exchange network, artifacts or records, leaves room for both diffusion and independent invention, perhaps occurring at different times. Societal implications deepen this mystery. If our ancestors had access to advanced knowledge and technologies beyond their known contexts, either these civilizations were far more advanced than current understanding suggests, possibly lost amid natural cataclysms or societal collapses, or their origins lie in a forgotten, more ancient civilization. Such a discovery would imply that human history is a complex tapestry of peaks and valleys, eras of brilliance followed by chaos and loss. The possibility of independent development remains compelling. Facing similar environmental challenges or celestial observations, humans might have arrived at astonishingly similar solutions, driven by necessity and curiosity, demonstrating resilience and ingenuity that surpass current assumptions. Yet, the evidence also invites us to consider a combined process, a blend of shared knowledge and independent innovation. Whispers of lost knowledge could have circulated among early cultures, inspiring new discoveries that appeared independently across regions. Over time, these fragments might have been lost through natural disasters like the Younger Dryas or societal upheaval, leaving us with incomplete records. Ultimately, these considerations suggest that our history may be far more interconnected and layered than traditionally thought. Our ancestors might have possessed technological and scientific knowledge, enabling feats once deemed impossible without modern machinery. Whether this knowledge spread across prehistoric civilizations or developed independently, the key insight is human capacity has always been remarkable. The idea of ancient advanced knowledge rewrites the linear narrative, from slow, gradual evolution to a tapestry woven with flashes of brilliance, lost and rediscovered over time. Our understanding of the past isn't straightforward but a complex puzzle, one that urges us to look beneath the surface, challenge timelines, and remain open to the possibility that human ingenuity has deeper roots and broader horizons than previously imagined. This rich history suggests both diffusion and independent development contributed to our technological origins, highlighting a more intricate story of human achievement. The existence of such ancient, sophisticated knowledge reshapes our view of human progress, from a steady climb to a dynamic interplay of rediscoveries and innovations. It emphasizes the importance of questioning established timelines and recognizing that human ingenuity may have persisted or resurfaced repeatedly through history's upheavals. This layered understanding prompts us to re-examine what we believe about ancient capabilities, societal development, and the true scope of human potential, an ongoing journey into our deepest past. Both diffusion and independent development likely played roles, resulting in a more nuanced and interconnected story. Ancient structures and alignments indicate significant intellectual mastery. Whether through sharing knowledge or parallel discoveries, our ancestors' capacity for astonishing feats exemplifies human resilience and creativity, challenging assumptions about prehistoric technology and societal progress. Exploring these mysteries suggests human progress isn't a simple linear story, but a complex web of rediscoveries, independent insights, and possible lost knowledge. Recognizing this complexity opens new avenues, questioning timelines, uncovering hidden capabilities, and appreciating human ingenuity. Our history may be richer, more layered, and more interconnected than mainstream narratives suggest, prompting us to see ancient civilizations as vibrant, highly capable cultures, masters of innovation and adaptation, whose achievements continue to inspire reflection on human potential. In sum, this layered, nuanced history reminds us that human achievement stems from both shared cultural exchanges and independent innovation, both essential in shaping our technological and scientific legacy. The evidence points to a past where human ingenuity thrived against odds, often surpassing modern assumptions. This ongoing journey into our roots invites continual discovery and re-evaluation of who we are, how far we've come, and how deeply our ancestors' knowledge and creativity were, whether through transmission or parallel discovery, more advanced than perceived. Throughout history, scattered artifacts and cultural remnants whisper of civilizations far older than accepted timelines. These enigmatic objects challenge conventional history, hinting that humanity's story extends much further back. When examined closely, patterns emerge indicating advanced knowledge and craftsmanship, possibly predating the Younger Dryas period. One fascinating category includes carved stones and monumental constructions that defy easy explanation. The Coso artifact, found in California's Coso Mountains, bears finely detailed markings resembling machinery parts such as gear-like patterns, astonishing considering the presumed tech level of ancient cultures. While some dismiss it as a hoax, others argue its precision suggests lost technological knowledge surviving through generations. In South America, carvings and artifacts hint at complex civilizations existing before the Incas. The Stela of Tiahuanaco, discovered near Lake Titicaca, features symbols and glyphs that many suggest are too sophisticated for its assigned age. These carvings depict astronomical scenes, machinery, and aerial perspectives with symbols echoing advanced celestial and engineering knowledge expected in much later periods. The giant carved stele in Bimini, Bahamas, presents weathered carvings resembling ancient airplanes or flying crafts, alongside sections resembling modern machinery. Despite debates about natural formations or coincidence, the consistency of such depictions across various sites raises curiosity about how widespread this lost knowledge might have been. In the Old World, artifacts from Sumeria and Egypt may suggest an even older timeline. Sumerian cuneiform texts describe gods and technology that seem remarkably advanced for their era, including skyships and machinery linked to the Anunnaki. Some interpret these stories as encoded memories of a lost technological era. The destruction and suppression of ancient libraries leave gaps in history, fueling speculation that an advanced civilization's knowledge was erased, leaving cryptic artifacts and narratives begging reinterpretation. Egyptian sites like Saqqara reveal fragments of skilled craftsmanship predating the Old Kingdom. Polished stones, strange metallic objects, and carved animals suggest earlier civilizations' influence. Hieroglyphs and symbols, when studied out of context, hint at astronomical or engineering knowledge predating accepted timelines, raising questions about Egypt inheriting ancient knowledge from more advanced predecessors. These artifacts form a puzzle, their pieces do not fit neatly into accepted history. Recurring themes of astronomy, craftsmanship, and technological motifs suggest continuous knowledge transfer, possibly older than the Younger Dryas, indicating a profound cultural memory surviving through cataclysms. Might ancient civilizations have inherited wisdom from older societies capable of monumental architecture and intricate stone carvings? The dating of artifacts like the Antikythera mechanism adds to the puzzle. This ancient Greek device, used to predict astronomical events, dates back 2,000 years, but demonstrates mechanical sophistication believed impossible for its time. Such devices suggest similar mechanisms could have existed much earlier, perhaps by lost civilizations. If ancient peoples crafted such complex artifacts, more advanced ones might still be waiting to be uncovered. Carvings and petroglyphs from Greece, India, and Southeast Asia depict ships, aircraft, or futuristic technology. Some images, thousands of years old, resemble modern airplanes or spacecraft. The Vimanas from ancient Indian texts are often depicted as flying machines, with images of engines, wings, and propellers. These descriptions shouldn't be dismissed as myth. They could encode real technological concepts passed down or stored within sacred texts. In North America, the discovery of advanced-looking Paleo-Indian tools and carvings adds another layer. These artifacts seem to demonstrate metallurgy or lithic engineering knowledge that would be lost for generations. Understanding these elements may require uncovering ancient knowledge networks that were disrupted by catastrophic events. Across cultures, myths describe a golden age, divine beings descending from the skies, civilizations lost to floods or fires. These narratives shared globally could serve as cultural echoes of a shared memory or encoded truths about ancient advanced societies. Whether literal or metaphorical, they reflect collective memories that might encode knowledge of technological prowess far surpassing current understanding. Examining these clues suggests a layered history, not a linear progression. It hints at civilization-building knowledge and technological achievements surviving through ancient memory, possibly passed down through symbols, myths, or sacred sites, despite cataclysms. The recurring motifs of astronomy, craftsmanship, and technological motifs suggest a continuous thread of knowledge. One of the most intriguing artifacts is the Antikythera mechanism, demonstrating advanced astronomical calculation for its age. If such devices existed earlier, it implies a history of technological development retained or lost over time. Similarly, carvings and ancient drawings of flying crafts or advanced machinery, like the Vimanas, may be hidden descriptions of real devices, transmitted through stories and preserved in scripts. Further, discoveries of surprisingly advanced stone tools and carvings among Paleo-Indian artifacts point toward lost engineering knowledge predating known civilizations. These finds hint at broad, interconnected ancient knowledge networks that suffered disruption during great catastrophes. Mythologies worldwide reference beings descending from the skies, myths of a lost golden age, and civilizations destroyed by floods or fire. These stories, regardless of their literal truth, serve as cultural memories of advanced societies. They might encode real knowledge and experiences of technological accomplishments at odds with current timelines, preserved in oral traditions and sacred sites. Together, artifacts, stories, and symbols form a provocative narrative. Humanity's past could be more complex than currently understood. These clues suggest that ancient constructions and artifacts indicate a shared, forgotten history. An ancient civilization with advanced knowledge, possibly wiped out by a global cataclysm like the Younger Dryas. This lost civilization's remnants survive in scattered relics, myths, and mysterious structures, waiting to be uncovered. The implications are profound. If these artifacts support the idea of an earlier civilization, human history's story becomes even more astonishing. A cataclysm may have erased much of this knowledge, leaving only scattered clues. Yet, through careful study, a new narrative emerges, one challenging traditional timelines and inviting us to reconsider how much remains hidden about our ancient past. This re-evaluation urges us to look beyond accepted history, recognizing that much of what we believe is incomplete. The collective evidence hints at a world where ancient builders possessed extraordinary knowledge, crafting monumental structures aligned with celestial cycles, developing devices for astronomical calculations, or creating artifacts resembling modern technology. These clues demand renewed investigation and open the possibility that the secrets of a more advanced ancient civilization still lie buried, waiting to be uncovered. The evidence we've examined points toward a revolutionary rethinking of human history, suggesting the age of the Giza pyramids and other ancient monuments might extend far beyond traditional archaeology's timeline. Instead of being products of civilizations emerging roughly 4,500 years ago, this evidence hints at structures and knowledge that could date back tens of thousands, even hundreds of thousands of years, to before the end of the last ice age. Such a scenario challenges everything we thought we knew about civilization, technology, and scientific understanding on Earth. One compelling conclusion comes from geological observations. Mineral formations, erosion patterns, and cosmic impact markers on the Giza Plateau suggest these structures endured cataclysmic events before the Younger Dryas, a severe climate cooling event around 12,000 years ago. If pyramids and related monuments predate this period, they imply that an advanced civilization capable of creating durable structures and moving large stones existed long before climate upheavals reshaped the landscape and perhaps human societies. The astronomical alignments and symbolism associated with the pyramids further support this theory. Scholars have marveled at how precisely Giza's pyramids align with cardinal points and celestial bodies. But what if this precision isn't coincidental, or only due to primitive astronomy? What if ancient builders possessed advanced cosmic knowledge, possibly passed down or lost during early Ice Age upheavals? They may have integrated astronomical events, solstices, equinoxes, lunar cycles, intentionally into their monuments to encode forgotten knowledge about the universe and humanity's place within it. Some researchers argue that the pyramids' mathematical proportions and the alignment of star systems like Orion's belt correspond to celestial patterns that could only be discerned through sophisticated understanding. This suggests that their builders weren't primitive workers, but members of a civilization with advanced astronomical knowledge. Such a civilization might have possessed technological prowess that rivals or surpasses modern understanding, challenging conventional views of ancient capabilities. Ancient myths and legends from around the world offer further clues. Many speak of a golden age, a time when humanity was more enlightened, technologically advanced, and closely connected to cosmic forces. Interpreted as memories or echoes of real events, these myths may reflect periods of extraordinary knowledge and spiritual development lost after cataclysmic disruptions. If true, they support the idea that civilizations with remarkable abilities once thrived, and that subsequent upheavals erased much of their legacy. The pyramids may function beyond tombs. They could be repositories of sacred knowledge, celestial maps, or gateways to understanding cosmic laws. The technological aspects of pyramid construction deepen this mystery. Precise stone carving, alignment, and transportation of massive stones are difficult to reconcile with known ancient techniques. Modern engineering struggles to replicate these feats without advanced machinery. If these stones were moved and assembled using primitive tools, it raises questions about ancient ingenuity, perhaps involving lost technologies such as sound, vibration, or energy manipulation, now forgotten or suppressed through history. The careful design of the pyramids and their astronomical features might indicate an understanding of energy fields or resonance, concepts only recently explored in modern science. Bringing these elements together suggests that human history is far more complex and ancient than conventionally believed. Instead of a linear progression from primitive hunter-gatherers to sophisticated societies, evidence points to a long-lost epoch when humans possessed advanced scientific and spiritual knowledge. This epoch may have been erased from collective memory by catastrophic events or deliberate suppression, leaving only monuments and myths as faint echoes of an advanced past. This paradigm shift questions the traditional timeline of human development and the origins of civilization. It indicates the existence of an earlier civilization, possibly interconnected globally, that understood the cosmos, harnessed energy, and built extraordinary structures. Such a civilization might have fallen due to cosmic impacts, massive volcanic eruptions, or climate shifts, destroying much of its physical evidence and knowledge. Recognizing these monuments as remnants of a highly advanced civilization would compel a re-examination of Egyptology, archaeology, and our entire understanding of human history, science, and spirituality. We might have underestimated our ancestors, who may have carried profound knowledge deliberately hidden, lost, or suppressed through ages of rise and fall. In conclusion, these clues suggest our history is rooted in a deeper, more complex antiquity than previously imagined. The Giza pyramids and similar structures could be portals into a forgotten era of mastery and cosmic understanding, an era that, once uncovered, could revolutionize archaeological scholarship and reshape our perception of human potential. We may be on the verge of rediscovering a foundational piece of our true origin story, one involving ancient giants, lost civilizations, or cosmic architects in shaping the world. The truth may be buried in Egypt's sands, waiting for us to uncover it once more. To assess claims that the Giza pyramids and other ancient monuments predate the conventional timeline, comprehensive research must be conducted. This involves re-examining human history, technology, and cosmic understanding. What steps are needed to verify or refute these provocative ideas? Primarily, more precise dating techniques are necessary. Current methods like carbon dating and geological analysis depend on samples that may be contaminated or not directly linked to the structures. Advanced methods such as luminescence dating or uranium series dating on the stones themselves could provide more accurate ages. Conducting tests at multiple locations within the structures, especially on undisturbed materials, is crucial. Cross-referencing results from different sites across Egypt and neighbouring regions can reveal if older construction dates are plausible, or if current consensus remains valid. Alongside dating the stones, detailed geological surveys of the landscape and bedrock beneath the pyramids could shed light on environmental conditions during construction. Geological markers suggesting earlier periods of activity or lost civilizations could support the hypothesis of an older origin. Non-invasive techniques like ground-penetrating radar or seismic surveys might uncover undiscovered tunnels, foundations, or buried structures. Finding such markers would bolster claims of an earlier epoch. Archaeological excavations hold significant potential. Revisiting the surroundings of the pyramids with new technology, especially in less explored regions, might uncover artifacts, inscriptions, or structural features indicating an older provenance. Advanced imaging, such as 3D laser scanning and multispectral analysis, can reveal faint carvings or markings invisible to the naked eye. These features, including hieroglyphs or symbols different from known Egyptian writing, could point to alternative cultural or technological origins. Astronomical studies must also be rigorously examined. The pyramids' alignments with celestial bodies are often cited as evidence of advanced astronomical knowledge. Precise modelling of ancient skies, considering precession of the equinoxes and other celestial shifts over tens of thousands of years, can determine whether these alignments could have been achieved earlier. If alignments match epochs before mainstream dates, this suggests ancient builders may have had an advanced understanding of the cosmos predating current records. Analysing mythologies and spiritual traditions from Egypt and elsewhere is equally critical. Myths often encode astronomical or historical truths that are lost in literal interpretations. Comparing motifs or stories might reveal clues about cosmic events, human origins, or technological feats beyond current understanding. Interdisciplinary work involving linguists, mythologists, astronomers, and historians can uncover shared symbols pointing toward an ancient knowledge system. Within a historical or environmental context, these stories could bolster the case for an older civilization. Experimental archaeology is another key avenue. Researchers can attempt to recreate ancient construction techniques using only materials and tools thought available at the time. Testing whether older methods of engineering or technology make construction feasible could support an earlier origin. If older models are plausible, this strengthens the argument for an older date. If reconstructions reveal insurmountable barriers with traditional assumptions, current datings might be reaffirmed or new interpretations explored. The scientific community must prioritize multidisciplinary collaborations, combining physics, archaeology, geology, and astronomy into large-scale projects with comprehensive databases could yield significant insights. Analyzing mineral compositions, structural alignments, and celestial data with AI and pattern recognition can uncover subtle clues or correlations missed by individual disciplines. Such an approach may reveal anomalies or promising avenues for further research, advancing understanding of these structures. The peer review process must be open-minded but rigorous. Discoveries challenging established views should be scrutinized carefully, with findings subjected to replication and interdisciplinary evaluation. Only through validation can claims of an earlier origin be accepted or convincingly refuted, maintaining scientific integrity. Engaging indigenous communities and local scholars is invaluable. Their oral histories, traditions, and cultural memories might encode information about earlier civilization phases. Stories sometimes contain clues about achievements or environmental conditions overlooked by formal science. Collaborations with local populations can uncover insights and preserve diverse perspectives, enriching understanding of the monument's origins. Developing and applying experimental archaeology, advanced technological scans, geological surveys, and astronomical modelling are essential. Large integrated databases compiling available data about these sites should be analysed with sophisticated algorithms. Machine learning and pattern recognition can reveal subtle patterns or inconsistencies, encouraging new inquiries. At the same time, the peer review process must be maintained as open-minded but rigorous. New hypotheses should be evaluated carefully, with findings replicated and scrutinised from multiple perspectives. Such diligence ensures the reliability of claims about earlier origins. Collaboration with scholars and communities, including indigenous groups, is vital. Their oral histories and traditions may contain insights about the monument's origins not present in official records. Listening to these perspectives supports a holistic approach, blending scientific investigation with cultural understanding. Each step aims to develop a clearer picture of human history. Validating an older timeline could reveal extraordinary truths, while refuting it would deepen our understanding of the past. Both outcomes challenge us to inquire further into forgotten stories and ancient wisdom. This process requires patience, openness, and skepticism toward assumptions, pushing the boundaries of knowledge about human potential and history. Such effort might surpass current paradigms, revealing that achievements are older and more remarkable than believed, possibly extending to eras where ancient humans performed feats only now beginning to be imagined. Imagine a future where science and technology converge with archaeology in ways we've only begun to dream of. Standing at the crossroads of history and mystery, new tools and perspectives could unlock secrets buried deep beneath layers of time, secrets that might push back the timeline of human achievement far beyond current understanding. Determining when the Giza pyramids and other ancient monuments were built isn't just about excavations or deciphering inscriptions, it's about harnessing emerging technologies and interdisciplinary approaches to peel back centuries of silence. High-resolution, ground-penetrating radar and non-invasive subsurface imaging are among the most promising advancements. These tools allow experts to peer beneath the surface without disturbing archaeological contexts. Instead of destructive excavations, these technologies can reveal hidden chambers, tunnels, and structural features that have remained concealed for millennia. In the Giza Plateau's case, such scanning could reveal architectural details suggesting construction methods or earlier layers of structures predating accepted dates. Unearthing evidence of earlier foundations could radically alter our understanding of the site's history, providing physical proof of advanced engineering from far earlier times. Advances in remote sensing satellite imagery and drone technology are transforming large-scale landscape surveys. These tools detect subtle terrain anomalies and composition differences indicating remnants of lost civilizations or previously unknown construction activity. Variations in soil or topography could point toward engineering feats that predate traditional timelines. Combined with Geographic Information Systems (GIS), these data can be woven into comprehensive maps revealing new insights into the extent and sophistication of ancient human activity. Technology also enhances analysis. Interdisciplinary studies incorporate fields like geology, astronomy, mathematics, and physics to interpret clues within monuments. Geochronology techniques like optically stimulated luminescence or uranium-thorium dating may be refined through collaboration to establish more precise ages for minerals and sediments associated with the pyramids. If calibrated to detect much older ages than current estimates, these methods could provide compelling evidence that structures are remnants of civilizations lost to deep time. Astronomical tools and celestial modeling software add another layer of insight. Ancient civilizations, like the Egyptians, encoded celestial knowledge in their architecture. Advanced computer simulations reconstruct star alignments, celestial events, and configurations from thousands or hundreds of thousands of years ago. If pyramids or other monuments align with phenomena visible far earlier than accepted dates, it might suggest their builders possessed an extensive understanding of the cosmos. Knowledge passed down through advanced early civilizations, artificial intelligence, AI, and machine learning are revolutionizing data processing and interpretation. Algorithms trained to recognize patterns in geological formations, artifact distributions, or architectural styles can identify subtle correlations overlooked by humans. An AI might detect symmetries or ratios indicating sophisticated planning, perhaps even awareness of astronomical cycles or advanced mathematics, concepts once thought inaccessible to ancient societies. Integrating these findings with other disciplines allows researchers to develop hypotheses about the technological capabilities of early builders, expanding our understanding of prehistory. Interdisciplinary studies also include cultural and mythological research, providing context for scientific data. Myths often encode observations of celestial or cosmological phenomena. If archaeological findings suggest structures were built or modified during cosmic events like meteor showers or planetary alignments, myth stories might reflect ancient astronomical experiences. Combining scientific evidence and myth analysis can produce a richer picture of how ancient civilizations perceived and possibly manipulated their universe with lost technologies. Material science breakthroughs enable unprecedented analysis of construction materials. Nanotechnology-enhanced spectroscopy, for example, can identify rare minerals or artificial alloys embedded in stones or mortar, clues pointing to advanced manufacturing techniques or extraterrestrial influences if such materials exist. discovering evidence that early civilizations manipulated materials or accessed unusual resources could transform perceptions of human technological evolution. Digital reconstruction and virtual reality now offer immersive exploration of ancient sites, even heavily eroded or buried ones. These tools recreate how pyramids and structures might have appeared historically, integrating archaeological, astronomical, and geological data. Walking virtually through reconstructed landscapes helps researchers and the public understand scale, purpose, and potential origins of these monuments, fostering fresh hypotheses about their builders and knowledge systems. These technological and interdisciplinary approaches foster collaboration among experts from diverse fields. Historians, engineers, astronomers, geologists, physicists, and mythologists exchange ideas that, when integrated, can shed light on humanity's distant past. This holistic approach minimizes disciplinary biases and promotes comprehensive interpretations, crucial for challenging conventional chronologies. The stakes extend beyond archaeology to our entire understanding of human history. Evidence emerging that civilizations built these wonders before accepted dates implies a lost chapter of technological mastery, cultural sophistication, and cosmic knowledge. Technologies capable of analyzing datasets, visualizing structures three-dimensionally, and detecting hidden features will accelerate discoveries. Each breakthrough brings us closer to rewriting history, piecing together clues from the ancient cosmos, and uncovering civilizations that mastered knowledge beyond current comprehension. In the future, advancements will open new horizons in archaeological research. The integration of emerging technologies and interdisciplinary studies promises to transform our understanding of human origins. By uniting science and culture, the quest to understand ancient feats gains momentum, inspiring us to see beyond current knowledge limits. This collaborative pursuit may ultimately rewrite the story of humanity's past, revealing a world of lost wisdom, advanced science, and cosmic understanding once thought impossible. Imagine a world where human history is fundamentally reshaped by evidence suggesting that ancient civilizations, perhaps even before the end of the last ice age, possessed astounding knowledge and skills long dismissed or overlooked. If the Giza pyramids and other megalithic structures were built before the Younger Dryas, around 12,000 years ago, then everything we thought we knew about human progress needs a serious re-evaluation. The implications stretch across archaeology, anthropology, astronomy, and our understanding of consciousness and technological development. Centuries have held that early humans, emerging from primitive origins, gradually climbed the ladder of civilization, developing language, tools, agriculture, and monumental architecture. This linear progression assumes a straightforward evolution of human capability. But what if that story isn't entirely accurate? What if civilizations, maybe multiple, reached remarkable levels of knowledge and engineering long before accepted dates, only to be lost to a cataclysmic event like the Younger Dryas? If so, our ancestors might have inherited a richer, more complex legacy than we currently acknowledge. Consider the staggering precision of the Giza pyramids, aligned with the cardinal points, built with stones fitting so tightly that even today's advanced seismic-resistant structures struggle to match such accuracy. For some researchers, this suggests a deep understanding of astronomy and geometry that would have been difficult with the tools attributed to ancient Egyptians centuries ago. If these monuments predate accepted timelines, then this knowledge might have come from a much older, possibly globally connected civilization. It could mean such constructions were part of a broader tradition, predating known history by thousands of years. This alternative timeline also prompts us to reconsider our ancestors' technological capabilities. Could they have harnessed advanced engineering, electrical technology, or cosmic knowledge that we've lost? Evidence of sophisticated artifacts and enigmatic symbols at sites worldwide, some resembling electrical conductors or batteries, raises questions about the extent of ancient tech prowess. If these artifacts are part of an even older tradition, then human ingenuity might stretch back far beyond conventional archaeology's scope. Furthermore, shifting the historical timeline sheds light on myths and legends from cultures around the globe. Many ancient stories speak of gods, giants, or ancestors with extraordinary powers or wisdom. If human civilization's timeline is moved back thousands of years, perhaps these stories are echoes of real beings or events from a time when humans interacted with highly advanced entities, whether extraterrestrial or terrestrial, who have since vanished. Such a revision also raises questions about human consciousness and the flow of knowledge. If ancient peoples had access to advanced understanding, how was such knowledge lost or suppressed over time? Catastrophic events like the Younger Dryas might have caused a reset, an apocalyptic civilization readjustment, forcing survivors to forget or be unable to pass down technological and astronomical insights. Consequently, our current knowledge could be just fragments or rediscoveries of a far older reality buried deep within human collective memory. The social and cultural implications are profound. Recognizing that our ancestors achieved a high level of sophistication long before traditional timelines suggest could challenge religious and historical dogmas. It might force us to reconsider concepts of divine intervention, direct inspiration from gods or spirits, or humanity's origin from a blank slate after legendary civilizations like Atlantis fell. Understanding that such an ancient high civilization might have existed could inspire new scientific and archaeological pursuits. It could lead to renewed excavations, reassessment of ancient sites, and searches for lost technologies, clues embedded in artifacts that might still hold the key to sustainable energy, advanced materials, or breakthroughs for today's technology. Uncovering ancient electrical tech or precise astronomical methods lost in time might revolutionize our understanding. On a broader level, this alternative timeline suggests human history is not a straight line, but a complex web of interconnected cultures, epochs, and rediscovered knowledge. Our true story may be much richer, filled with mysteries that challenge surface-level narratives and push us to question our origins. It also influences our understanding of our place in the universe. If ancient civilizations had contact with extraterrestrial entities, sharing or receiving advanced knowledge, then human history could be part of a broader cosmic narrative. We might not be mere beginners, but inheritors of a legacy that spans millennia, or even millions of years. In essence, pushing the date of monumental constructions like the pyramids back thousands of years opens a Pandora's box of questions and possibilities. It beckons us to rethink human evolution, the rise and fall of civilizations, and the scope of ancient knowledge. If humanity's true deep history is far older than believed, then our potential, our creativity, ingenuity, and curiosity must be re-examined. The lost chapters of our past could be waiting to be uncovered, hidden in plain sight, ready to revolutionize how we view ourselves and our cosmic origins. Challenging established narratives is not just an academic exercise, it's a fundamental act of human curiosity and intellectual freedom. Questioning accepted histories, like the notion that the Giza pyramids were built only around 4,500 years ago, opens doors to a broader understanding of our past, our ancestors, and the incredible capabilities that might have existed long before mainstream archaeology suggests. It pushes us to expand what we think is possible, and daringly consider ideas that could reshape entire civilizations' histories. For centuries, human progress has been viewed as linear, ancient civilizations rising, reaching their zenith, and then declining in a neatly ordered timeline. The pyramids, for example, are traditionally placed in the Old Kingdom of Egypt, built by skilled artisans and labourers financed by pharaohs. This narrative has been reinforced by archaeological evidence, carbon dating, and inscriptions, until recent discoveries cast doubt on these assumptions. Questioning these timelines invites us to consider that human history might be more layered and intricate than a straightforward sequence of events. It compels us to reconsider what ancient peoples might have accomplished. Could they have engineered feats that today seem miraculous? Might they have possessed advanced technological knowledge, or collective memory that's been lost over millennia? The significance extends beyond merely rewriting history. It prompts a re-evaluation of human development, our cognitive, technological, and cultural evolution. If the pyramids predate known dates significantly, what does that imply about technological sophistication at the time? Were ancient civilizations in possession of knowledge that has been suppressed or forgotten? Exploring these questions suggests that human history is a tapestry, woven with long-forgotten innovations, stretching deep into prehistory. Challenging accepted narratives also fuels scientific and philosophical curiosity. It fosters an environment where questioning dogma is welcomed, and where evidence, no matter how revolutionary, can be thoroughly examined. Accepting stories without scrutiny risks stagnation. It fosters intellectual complacency and stalls discovery. History shows that breakthroughs often stem from individuals daring to challenge prevailing views, whether early astronomers questioning the geocentric universe or scientists questioning combustion. Such challenges led to revolutionary leaps in understanding. Moreover, questioning can inspire new generations of thinkers, archaeologists, and explorers to interpret data differently. It encourages interdisciplinary collaboration, geology, astronomy, engineering, mythography, that might uncover overlooked clues like ancient artifacts, geological anomalies, or celestial alignments supporting an older, more complex human history. These challenges resonate beyond academia, touching on cultural identity, religious beliefs, and societal values. For some, accepting that ancient civilizations might have possessed advanced technology, predating what's accepted, challenges long-held narratives about human origins. Yet, it can also serve as a bridge, fostering humility and shared discovery. It prompts us to see our ancestors as capable and wise, inspiring renewed respect for their achievements. There's a strategic aspect too. If ancient civilizations had access to lost technologies, their knowledge could inspire modern innovation. Learning from their engineering, astronomical observations, and material sciences, possibly ahead of their time, could spark modern revolutions. Recognizing that our ancestors might have harnessed long-lost knowledge reminds us that technological progress can recur, fueled by rediscovering ancient practices. The Renaissance rediscovery of manuscripts exemplifies how ancient knowledge fuels scientific advancement. Challenging mainstream views often faces skepticism, especially when it threatens rigid paradigms. This resistance highlights the importance of maintaining a scientific mindset, evaluating evidence critically but openly. No story about the past should be beyond scrutiny. Progress depends on humility and the willingness to revise models as new evidence emerges. Ultimately, questioning the story of the Giza pyramids and ancient civilizations is an act of liberation, freeing us from intellectual captivity and inviting us to see history's potential complexity. It encourages looking beyond stones and inscriptions to embrace a richer, more mysterious tapestry of human history. It reminds us that human ingenuity may have flourished in ways still beyond our comprehension, fostering humility, curiosity, and a relentless pursuit of truth. The real significance lies in the possibility of reshaping our understanding of human origins, possibly uncovering a forgotten chapter where humans achieved extraordinary feats long before believed possible. Challenging these narratives isn't just rewriting history, it's reimagining what it means to be human and recognizing the vast, untapped depths of our collective past. By questioning, we open the door to discoveries that could profoundly alter our perceptions of history, ourselves, and our potential. The message that resonates through these discoveries is that the pursuit of knowledge is a never-ending journey, one that demands curiosity, open-mindedness, and a willingness to challenge long-held beliefs. As we peel back layers of history and examine evidence suggesting the Giza pyramids may be much older than previously thought, we're reminded that our understanding of the past is constantly evolving. What we accept as fact today might be a stepping stone toward a deeper truth tomorrow. This quest isn't just about uncovering dates or relics, it's about questioning assumptions. For centuries, the narrative that ancient civilizations like Egypt's reached their peak around 4,500 years ago has been accepted, but new evidence, geological anomalies, astronomical arrangements, mysterious artifacts, pushes us to think differently about what those civilizations could have achieved. Instead of viewing the past as primitive or static, we see it as vibrant, complex, and perhaps filled with advanced technologies or lost knowledge yet to be fully understood. Such discoveries serve as important reminders that human history isn't a straight line of progress. Instead, it's a tangled tapestry woven with innovations, disruptions, rediscoveries, and influences from unexpected sources. When considering that ancient builders might have used techniques or technologies we deem impossible today, we realize how limited our perspective can be. Our search for truth challenges assumptions and encourages creative thinking, fostering a mindset that values evidence over dogma. Questioning and exploring emphasize humility and knowledge-seeking. No matter how much we learn, there's always more that remains hidden or misunderstood. Archaeological revelations have overturned previous theories about the Giza pyramids' age, and future findings may unveil even more astonishing truths about early human achievement, or possible extraterrestrial influence. Recognizing that history may be more complex than imagined opens new doors to understanding who we are and where we come from. Moreover, the pursuit of knowledge fuels innovation and progress. The engineering feats of ancient builders who use seemingly primitive tools continue to inspire us to think beyond current limitations. They show human ingenuity, resilience, and a desire to leave a lasting legacy. Their accomplishments, shrouded in mystery, challenge us to harness our creativity and problem-solving skills to tackle today's challenges. Every discovery and question pushes us toward new horizons, reminding us that breakthroughs often come when we dare to venture into the unknown. It's vital to recognize that this quest is collective, involving scientists, historians, archaeologists, engineers, and curious minds worldwide. Collaboration is key to piecing together our past, and each new perspective illuminates overlooked details. The more diverse our approaches, the richer our understanding. This collective curiosity fosters a shared human heritage, emphasizing that no single culture or era holds all answers. We are part of a continuum, building upon the knowledge and mysteries of those before us. Exploring ancient enigmas also reminds us to remain open to new ideas, even when challenging authority or conventional wisdom. Questioning accepted narratives can be uncomfortable, but progress often requires skepticism and imagining alternative possibilities. This openness fuels innovation, inspiring scientists and scholars to think beyond disciplinary boundaries and craft new theories that could revolutionize understanding of history, technology, and human potential.